going to talk a lot about different approaches, what the trade-offs are, and far, far less about the technology. One really common pitfall is just reading the front page of these technologies. Dynamo is another one that comes up, Yugabyte, Kafka, whatever. They're going to pitch to you all these great benefits, and they're going to say, it's so flexible, it's useful in all of these cases. You're really going to have to dig for some of those trade-offs. If you don't understand this well, if you don't understand what you're trying to solve, you're going to end up in a bit of hot water. You're going to end up with a delayed or incomplete solution. We haven't really gone through the requirements, so who knows what we're really building. If we're going to have a lot of back and forth with product after we've already done a lot of upfront design, there's going to be delays. It's going to be, oh, but I thought we were going to build it this way, not that way. If you don't talk to product at all, they're going to think you're building one thing, and you're going to have built another thing. Your solution is going to be incomplete. It's also going to be expensive. You haven't really done much to look at where your data is going, look at what compute you're going to need. So you're going to end up throwing a lot of hardware at it, which is going to come at a lot of cost. It's also going to be unreliable. We've put up design up there, but how much throughput are we actually trying to handle? How much load does our system need to be able to support? And of course, it's going to be buggy as well, especially if you're going to go with those hot new databases with a lot of eventual consistency. But we're going to go through that later. So your interviewer is very nice, very professional, very polite. She's going to let you down gently and just say, I don't have any more questions. Why should she? We haven't really demonstrated our ability to explain our decisions, so she's going to save everyone time. As I mentioned at the start, we've made a few different mistakes here, but I'm going to take a shot at distilling it down into one really, what I think is a common cause. And giving it away a bit early, but I really think the mistake is unintentional design. What I mean by that is we can get very caught up in applying best practice, the newest technology, the one with the most purported benefits. The problem with that is when we're asked to explain these decisions, why did we pick this and not something else, we might not be able to explain that. And that's kind of what I mean by unintentional. If it was an intentional design, we'd much better be able to say, yes, this is why we chose it. What we've actually done is really sidestepped thinking about the problem and just gone for a lot of shortcut heuristics, right? Which I think best practices can be sometimes. So let's try this whole process again, but this time we'll do it with a bit more intention. So let's wind back the clock. What is system design? And I just copied this straight from Wikipedia. It's defining the architecture. Well, we've got a diagram, so I guess we have an architecture. We have product design. Actually, no, we don't have product design. Modules, interfaces, data. We ain't got that. We haven't really talked about it. We don't have requirements to start with. Now, the product design part is easy. We're just going to blame product. We'll just stonewall them off, deliver our solution, and then fall over. What we actually want to do is really collaborate with product, or your interviewer, or just your team in general. I think this works both ways. Product may simply throw requirements over the wall and not really want questions, so you can do this one in reverse as well. You deliver a solution and blame engineering. If your company's particularly low on funds, you can blame each other as much as you want while you're packing all your things into your boxes because we failed to launch. So, onto the walkthrough. How are we going to get ourselves out of this mess where we've thrown together a really unintentional design? The first place to start is functional requirements. What are we actually trying to build? When we have a discussion with product, what are we going to talk about? We want to have a common understanding of what we're trying to build. So, winding back the clock, we want to design a social media application where users can share messages with their friends. So, what are the key features? What things do we need to provide so that customers can do that? The first thing, users do need to be able to post messages. That's an important one. We also want to make sure that people can share these messages with their friends. How they're going to do that is by following each other. And we also want to make sure that you've got a nice feed of what all your friends are saying. I think we can focus on these three. What I want to stress is that you don't have to design every part of your application here. You want to spend most of your time, most of your effort, looking at areas or features where either your product has a lot of risk around it, a lot of risk around that feature, or where you're really going to extract a lot of competitive advantage. And I think if we get these things right, at the very least, we do actually have a social media platform. So what about those things we left by the side? Let's say authentication, for example. We can talk through that. So for authentication, there's a lot of nice patterns for doing this. I want to say it's a largely solved problem. I'm going to tell my interviewer that they're going to be okay with it, and we're going to move on. If they're not okay with it, of course, you're going to have a bit of a chat about it. So we've made some progress here. Just by refining the functional requirements, we at least know what we're going to build, what our product is going to look like. There's less risk of your solution being delayed or incomplete. You still have all these other problems, though. How are we going to deliver these use cases to our users? So we're going to move on to non-functional requirements, the things that aren't features, but we really need to think through. And I think this is where it gets really interesting. Actually, I'll expand a bit more on that. To be clear, these are going to be things that our application needs to support. It just isn't a feature. Users aren't going to be too aware of it, and you're not going to put it up on your website. So, throughput. How much traffic does your site need to handle? There's two major ways this gets split up. Read throughput, so reading against your data stores, reading against your services, is usually pretty easy to scale, and scale horizontally too. Write throughput is a lot tougher and comes with a lot of trade-offs, which we're going to discuss later. So do we need to go away for a few weeks and talk to our data team and really get an exact picture of how much traffic we are handling, how many users we have, or if we haven't launched it, how many users we're going to have? Not really. We can be pretty rough about it. We just want to get a rough picture of, is it a lot of throughput? Is it a little bit of throughput? So we can start with some napkin math. A pretty standard prompt for this, we can just ask, hey, how many users are we expecting to have? We're going to get back a number, and this is something collaborative product, or if it's an interviewer, they'll likely just hand it over to you. Let's just say we have 100 million users. From that, we can start to build a picture. We also need to know what they're going to do in a day, right? We want to know what is going to be hitting our services. So, we can kind of go with our gut feel here. We're going to say, oh, an average user is going to post up 5 messages a day. They're going to follow one of their friends. And they're going to doom scroll a little bit and have 20 views per user per day. Sure. So we can start to get into some rough maths. If we have 100 million daily active users and we have 5 messages a day, that's 500 million messages a day, or about 6,000 requests a second. If our users are following one other user a day, 100 million follows a day, 1,200 requests a second. Those are both write ones. Those are both write throughputs. That's how many write requests we're going to need to handle. Look, it's kind of around the mid-range. The last one is reads. we're going to have to do 2 billion reads a day. 20 users requesting their feed every day, per user per day. So 24,000 read requests a second. It's getting up there. We'll make a note of that, and we'll come back to that later. That's going to help guide our design. We also need to take stock of availability. So availability is our system's ability to fulfill a functional requirement. It needs to succeed within a certain span of time. Why is that important? If users on our app try to send a message and they keep getting errors, or it takes 30 seconds every time you post a message to get a confirmation, it's going to be a pretty crummy experience. Again, and I'm going to hammer this in so much, it's in collaboration with your product team. Well, with your wider team, really. We're going to say our users, most of the time, get a response within half a second when they try to send a message. It feels about right. Again, we can kind of use our gut as long as we're setting these expectations with product. We can follow when we go to click follow on another user, it succeeds most of the time within about 2 seconds. It's done less often and users will kind of just accept it. That's what we think anyway. We don't have to get it perfectly right. We can always refine these things, tune our solution after we launch, as long as we've set our expectations with product. The last one is really important for our product. We want to encourage, well, it's engagement, right? We really want users to get stuck in that loop of just scrolling and viewing all of their friends' posts. So that really needs to be really quite reliable and happen pretty quickly. You don't want them waiting, or if they get an error screen, they could very well leave, right? We'll make a note of that and come back to that later. Consistency is a really interesting one as well. Consistency deals with guarantees. So what are the characteristics of our system when we write data and read data back from it? It's a whole huge topic all by itself that I'm not going to go into, but we're going to use two major models to categorize it for today. We have strong consistency, where all of your accesses are seen in sequence. That maybe sounds a bit babbly. The important thing is, this also means when we write data to our stores or write data to our services, as soon as we try to read it, we're going to get the latest state back. It's strongly consistent. On the other end of the scale, and I promise we'll get something for this, is eventual consistency. So with eventually consistent systems, you're going to have all these updates coming in, but when you go to read, at any time, they might have said, yeah, we've accepted this write, we've accepted this new data, but you might not get the latest data. The only guarantee this gives you is that if writes stop coming in, we'll eventually get the latest state. Let's take an ordering app, for example, Amazon or something. When we go and order a new book with a strongly consistent system, when we go to our order history, we're going to see, oh, the new book we've ordered. Cool, easy. If we have an eventually consistent backend, what we might see is we purchase a book, we go to the order history, and there's nothing there. That sounds really bad. In that case, how can eventual consistency be feasible? There's actually a lot of ways around this, but almost all of them will add complexity or otherwise impact the user flow. For example, you might just say, hey, if you've ordered in the last 15 minutes, it might not show up here. You might also just choose to show a spinner or something rather than show a stale state to put the customer at ease. Either way, you're adding complexity to application. And I did promise we'll get something in return. With strong consistency, we get these nice, consistent views. It's very easy to use, easy to debug, easy to reason about, easy to write. It's very nice. one thing we can do with eventually consistent systems is really scale out our writes. With a lot of these strongly consistent stores, it's difficult to scale these writes horizontally. We can't really have a cluster of write nodes. That's not how it works. Instead, let's say we have our big SQL Server database. All we can really do is scale it up and up and up. You're going to hit limits there in what you can actually provide, and it's going to be awfully expensive. With eventually consistent systems, we're basically accepting, hey, I don't mind if this system returns a stale result. I'd rather be more available. This also means we get there's a lot of techniques that now become available to us to improve write throughput. A lot of those hinge on things like asynchronous replication, making sure that a log of our transactions can be sensibly replicated to all of the other nodes in our cluster which are handling a little slice of our write throughput. So that's consistency. And I should come back a little bit on that when we go and talk a little bit more about databases. So how does it actually matter for our application? Is it okay if a user's feed doesn't show a message that they've just posted? Potentially. It's not nice, but we know we want to handle quite a bit of throughput here. And for interest's sake, we're going to say, yeah, we want to make that eventually consistent. We'll accept a bit of complexity in our application. With follows, it's a bit more hazy. If you follow another user, do you necessarily expect to see all their messages in your feed right away? I think that's a bit more of a gray area. You could argue that, hey, if I'm interested in what this person has to say, I want to get their messages right now. But there could also be a case made that we want to have that extra performance, and we don't mind if it takes a little while for those friends' messages to show up. With viewing our feed, I'd argue it's much the other way. We can accept if one of your friends posts a new message, you're not going to see it right away. It could be 5-10 seconds, it could be a minute. Again, one of those things you really want to drive with product. As long as the expectations are aligned, I think we're in a good place. So let's discuss that with our friend, our interviewer. Is it okay if the feed's sometimes out of date? Sure thing. Andrew is very nice. She just says yes to whatever we say. The last one here, a little bit more routine. Where is all this data? Where is all this user data going to go? If we've got terabytes and terabytes and terabytes, we need to store it somewhere. We don't want to go and run out of disk space in our database halfway through or run out of some other store. Another one that we're not going to go too much into is the durability of your data. Don't always assume you need to store all of your data. There's actually many cases where you're going to receive user data and you're either going to store it temporarily or you're going to store it somewhere transient. You don't care if that machine crashes and that data goes away. It's nice to have. So similar to what we did for throughput, let's do a little bit of napkin math to see how much data we need to store. We're going to put up a little bit of a simple schema here. I hope it's not too controversial. Just a unique identifier for the message. When it was created, we'll generate that server side. A message, and a little bit of metadata around it. The metadata gives us a bit of flexibility. Maybe we'll want to stuff something in there later. That's not the point. The point is we've got about 250 bytes of data here per row. We already know. We've gone and asked how many users we have, how many messages we expect users to post each day. And I hope my maths is right here. That should be 125 gigs a day or 40 terabytes a year. This does matter. I use Postgres Aurora a lot, my day-to-day. That has a database limit of 128 terabytes. That means within a few years, we're going to start to have to start deleting data. Or we can have a look at an archiving process up front. On the other hand, be careful of other limits as well. We just ran into a problem where one of our tables is starting to exceed, it's getting really close to its limit. Postgres has a limit of 32 terabytes. Know your technology. So now that we've gone through what our app needs to support, both from a functional and non-functional sense, we're going to go with something a tiny bit more esoteric. It's the schema. How are we going to send this information around our system? We don't need to talk about it in too much detail, just enough for us to reason about the parts of our system. Remember our 3 use cases. We want to be able to post a message, we want to be able to follow other users, and we want to be able to view other users' feeds. You can see this is missing a whole bunch of stuff, but we've got the key points here. You want to post a message, you include your message. You want to follow a user, you include the user ID. You want to view the feed, you're going to just send a request and you're hopefully going to get back a big list of messages. The last part ties it all together, but I think it's actually probably the least juicy part. So if we go back to the very standard looking stack we had before, how are we actually going to talk to our services from our client? I think what I've seen a lot is people are going to generally default to REST. And that's what I really want to hammer down on or push back on. We don't want to be in the habit of defaulting to certain technologies. And it's our instinct because we develop expertise with these specific technologies. Same with our database. A lot of the time it's okay, but I'd like us to be a bit more intentional about how we design these. Instead of saying, we'll just use SQL Server because we have that there, and I know how to use it. A quick overview of some of the other things out there that aren't REST. I'm not going to go too much into REST. I think most of us are pretty aware of how to use it. We use it a lot in our day-to-day. It's mature, it's battle-tested. It caches really nicely too. But what about the other stuff? Should we hop straight to GraphQL? GraphQL is really cool, right? We can do a declarative query. Instead of being beholden to different endpoints, we can say, hey, I just want this data. I want to get these messages and from these users. It's really nice for the front-end teams. Also cuts down a bit on how much data we need to fetch. With your REST endpoints, you generally get the whole resource back. With Graph, you're only going to get what you asked for. gRPC. It's fancy, super fast to deserialize and serialize data because it's just going to send binary representations over the wire. Why don't we just use that instead? Well, browsers don't have very good support for it, so if you want to use it for users to send requests to your server, you're going to need a proxy in between. So adding complexity there. It is, however, very, very nice for server-to-server comms. There's trade-offs with that, but if you have massive scale, these are things that are going to save you a whole lot of money, really going to cut down on how much compute you need. I promised to talk a little about databases. Where are we going to put our data? A lot of the time, we're going to default to one of these, right? We're going to default to Postgres. I love Postgres, I love SQL Server, I love MySQL. These have a few things in common. They run off a relational model, and they're going to generally have one write node and support for read replicas. And I know there's plugins which may let you do more replication and sharding around that. Generally, I think all of these are going to be strongly consistent. They just have that one writer node. If it's in a case where it can't send you up-to-date data, it's going to fail instead. The system will become unavailable, and you're going to get nothing. The benefit of this is, of course, it's much easier to design your applications. You don't have to deal with a lot of eventual consistency, which you are going to have to deal with a lot in NoSQL databases. A lot of these will say they provide strongly consistent reads, but there's going to be a lot of asterisks around that. Once we release ourselves from that requirement to have always up-to-date information, like I said before, a lot of techniques become available to you to support more availability and more throughput. Even semantically, you're going to get more availability simply because the system will say, it's fine that I'm out of date, here's your data. So that's that big trade-off. Are you willing to accept eventual consistency if you're going to get a lot of throughput and availability out of it? There are ways you're going to get more complexity in your system, in your applications, or you're going to affect the user flow in some way. We also want to talk about data flows. So how data flows through our system. Now that we've got a bit of our schema, we can have a think about, okay, these requests are coming in. Can we do some pre-computation so that when the user goes to fetch a certain piece of data, it's already there hot in the cache or in a server somewhere? As a little bit of a flip side, you have caching. Once you've done a bit of work to compute something, maybe someone's feed or something like that, why not just save it somewhere so if they ask again for it, we can bring it back quickly. We don't want to have to do all that work of looking up who are their friends, what messages have their friends sent to build that picture every time. It's a lot of work. There's concerns around this as well. Your caching layer can fail. You don't want your application to become unavailable, so there's complexity here, again, for performance. It's a common theme, right? So I'm actually going to give you something that's not particularly, it's not a perfect architecture or even a great architecture, but it's something that I can back up. It's something where if you ask me questions about it, I can at least give you some amount of explanation about why I've done things a certain way. I've cut out the static assets part. That's a bit less interesting. We've got our three main requests: posting a message, following another user, and getting a feedback of what our friends have said. So going back to talking about picking the right technology, and I'll add some caveats into this later, we've put in a GraphDB for our social graph service. We've got something optimized to help us get a list of friends for a certain user. Graph databases are pretty cool. They store relationships as a first-class thing, not the element themselves. That means when you're looking for relationships based off a certain node, it's going to be much faster than doing the same on a relational database. A lot of these are eventually consistent, but as we said before, we're going to go accept that. We've discussed that with product. It's okay. You're not going to get your friend's latest messages right away. Similar when we post a message. So we can do a bit of pre-computation here. We don't want to lose these messages. That would be bad if everyone just, you post all these messages and you want to see them later, reminisce about what you and your friends have been talking about. So we'll put a database up there somewhere. Could be Postgres, could be Mongo. They'll both work. But we're also going to send something to an asynchronous worker, a feed updater. So when we know that a message has come in, we're going to go up and update your people who are following you. We're going to inject this new message into all of those feeds. That means if we've done a good job keeping our caching layer consistent when requests come in, a lot of users, especially for the active users, you're going to get your feed right away. Our service can do a whole lot less work in generating users' feeds. So it's in considering things like that I think we get a lot of value. You can explain your decisions. You're explaining why you're using something and not something else. You're picking the right technology. There's next steps. There's things I haven't covered. So moving forwards, doing a bit better than this, you want to find ways where you can deal with less data. And that's where we kind of talked about, can we pre-compute something? Can we cache something just so we have less data that needs to be computed on the fly, sent to here and there? Picking the right tool. So really reasoning about what, I'm using this technology because this. I know it's got these cons, but that's okay. And we're all in line with product about that. I've also haven't talked about some of the more, for example, sharding. It's going to improve your write throughput, but that's kind of a whole topic in itself. There's more complexity there. How are you going to split your data up among different shards, things like that. Few edge cases as well. While our solution works well for cases where users don't have a lot of followers, because that little async worker is going to go and update people's feeds. If we have Lady Gaga come in with 30 million followers and post a message, that's going to be massive write volume. These are the kind of edge cases that you want to think about. There's a cautionary tale here as well. You don't want to be, when you're picking the right tool, you also want to think about your team's skill set. There's not much reason to adapt a technology. There's a few ways you can approach it. Either you tend to shy away from using a technology that your team doesn't know how to use, or that you think you're going to have difficulty hiring for. Another way, and this takes a lot of effort, is to drive consensus among your wider engineering team about adopting a technology because it allows us to do X, Y, Z. And I can't stress how much effort and how exhausting that can be, even in the best run organizations. You want to look at procurement as well. There's going to be a lot of people in the company who are going to be pretty unhappy if you're like, I want to grab this technology, going to grab, Cockroach here, and I like this from AWS, and I like this from Azure, and I like this from GCP. It's going to be a real headache. There's contracts here that need to be negotiated. There's money. It's a lot more work than it might appear at first thought. And there's always, you aren't going to need it. I think we have a natural tendency to want to avoid maybe future uncertainty or future risk. So we can end up over-engineering our systems. We'll put this big, eventually consistent system in place and spend a lot more time working around the complexities of that than building out our core system. So please, 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 there's a lot of, you aren't going to need it. You can apply here. Remember what your competitive advantage is and focus on that. There generally is time to scale up later, to do a bit of re-architecturing if you're doing well. So with this, we're doing a bit better. We've maybe adopted gRPC for our service-to-service comms. We know what sort of throughput we need to handle, and we have a plan in place for it. And product isn't getting any nasty surprises. We've reasoned about how our system is going to perform, how it's going to behave for customers. It's always going to be buggy. I don't think we can solve that one. That's a tale for a different day. The point is, we're not trying to completely avoid failure here. We're just trying to make sure we do our due diligence and we've reasoned about our system sensibly. So the key takeaways, just quickly, please, 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 talk to product, ask lots of questions. We need to stop this habit I still see of waiting for product to give us our requirements, or product just giving the engineering team requirements and not really expecting any questions. We can get a lot of value out of just talking. Again, design with intent. Explain why you've chosen something and why you haven't chosen something. Design often. You're going to do this a lot at your workplace. if you get into this good habit, you're going to you're going to build a lot of experience. And system design is something that does take a lot of experience, but if you get in the habit of thinking about it the right way, it's really going to improve your ability to reason, design. Makes sense, right? Practice. On the side, there's so much great information about there, white papers, tech blogs, videos. Go and do your study. Look at how Twitter's built. There's lots of stuff out there, Instagram, Netflix. There's so much free material out there. You can kind of run through why they did it a certain way, and then take a step back and try to design it yourself. Cool. Thank you very much.
Follow the recipe. I just follow that recipe and innovate.
Yes, something like that. So,
Very good.
At the interview itself, you just want to follow in a structured way, and this was actually something that we really agreed was a really nice structured way of doing it. Non-functional requirements, functional requirements, like how much traffic your servers are going to need to handle, schema, stuff like that. You just want to be able to explain these things, and it's so important when you're talking to stakeholders or senior engineering leadership as well.
So I can use that throughout my working life, really.
Absolutely, absolutely.
Perfect. Okay, so I'm going to open up the floor for a Q&A session. Does anyone have a question for Nick? Okay, this man over here, please.
Hi, Nick.
Hey.
Working? Yeah. Well, thanks for excellent talk. So you mentioned, always reason about why you choose one tech over the other.
Mm-hmm.
And it's built on the assumption that you know all the tech and you pretty much, you know what's out there, you know alternatives, you know pros and cons. What's like the best behavior if you deal with some systems that you don't know much about? Like, I don't know, someone told you to design time series heavy application and you don't have a previous experience. So how would you, operate in these kind of situations?
Yeah, that's a really good question. If someone approached me and said, hey, I'd like to build this with a time series database, I'd basically say, why? The first thing you want to ask is, what are we trying to solve? What is the problem that needs a time series database? For example, if it's something like, obviously time-based, right? Like a lot of your observability metrics, something like that, then sure. It's not something, I'd probably discourage people from trying to deep dive into everything. That's not something you can do. Instead, you want to have awareness of the different classes of database. So you've got your, Y column stores like Cassandra, or your time series database, like you mentioned, graph database, and so on. As long as you have an awareness of it, then you can go back and say, hey, okay, after our discussion, it looks like the time series database is the right way to go. I don't have much experience on this. I'm going to have to do a bit of a deep dive on it. And I think that's a plenty reasonable path forwards. Does that kind of answer the question?
Yeah, thank you. And if you're in an interview, for example, and they ask you to design something that you haven't built before,
Mm-hmm.
is it a good idea to speculate or articulate or say that you don't know much about it or make a best guess, or what would be that kind of scenario?
I think in the interview, so what can happen is if you throw out technology you aren't very confident about, it can really fall apart. And that's why I stress it's so important to learn about the underlying concepts of how these things work instead, rather than saying, I need to know Mongo, I need to know SQL. You want to learn about how SQL databases operate, right? So at the lowest level, they've got these logs that they need to make durable, and from that, they'll kind of project some data out of it. With eventually consistent systems, you've got distributed rights, and then there's some work there around gaining consensus around what data's there, that kind of stuff. So my best advice is to really focus on the concepts that power these technologies. Don't focus on the technologies themselves too much. If you do this well, you can actually look at what benefits a new product proposes and say, I reckon they did it this way. And if you're getting that right often, and if you're able to say, I reckon Cockroach does things this way. They say they've got these secret sauce, but I reckon it's something like this. If you can start, looking at that level, you're really on the right track, I think.
Thank you.
Thank you.
Another question?
Yes, T.
You mentioned a tip if you have how you go about that discussion with products. How do you actually drive that? I think that was a great takeaway for me. Yeah, thank you.
Yeah, so that's a good question. It depends on your organization a lot. If it's a very hierarchical one and you're just getting tickets over the fence, it's a lot of work to go and breach that gap. But I think generally, you just act in good faith. For example, if you go to a product person, to someone who's a real decision maker, and you say, hey, here's what I've been asked to build. I'd like to know what the problems we're trying to solve are and really get some consensus on what we're trying to deliver. I think most people will be very open to that. I think a lot of non-engineering people would take to that really kindly. I hope that answers your question.
Is that the last question? Any more? Okay, well, I've got some good news. Morning tea is served in the foyer, but a big thank you to Nick.
Thanks, everyone.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking
God,
at
this is like my dream come true. I've always wanted to join Scott Henselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the Ultimate Keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
Hey, bigger customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Huh. Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking
God,
at
this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never, ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Pink Beret. As you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the pink, no matter the client, no matter where I was working, it always was a pink background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so pink beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Yeah, whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want? me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. But I really needed to wind down before bed, so I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Our next speaker is Dylan Watson. He's going to talk to us today about releasing your inner DevOps. Dylan is a fan of cheap wine and fast deployments. He has spent the last 5 years improving the pace of development at Bankwest and has recently started with Atlassian, building out their internal continuous deployment platform. When he's not building out the latest harebrained app idea, he is playing on the trampoline with his 2 kids. Welcome, Dylan.
All right, cool. Welcome, guys. So basically today I want to talk about how to build a culture of getting your code into production quickly, safely, and reliably. Okay. thanks heaps to all our sponsors. Without them today, wouldn't be possible. Okay, so first I want to start off with a bit of audience participation. Everyone loves a bit of audience participation, I'm sure. Oh no. Okay, try not to touch. Okay, so if everyone could put up their hand if your team has deployed something to production this year. We'll start, ideally, a low bar. So keep your hand up. Keep your hand up if your team deploys more often than every 6 months. Cool, all right. What about every month? Okay, few hands down, but still pretty good. Okay, every week. Does your team deploy every week? Yep, few less hands. What about every day? Yep, much less hands. And what about every commit? All right, cool. There's a few people. Awesome. For the rest of you, it's definitely possible, right? And today I'm going to show you a few techniques that you can use. Maybe not necessary to get there, but to improve your deployment process, okay? I'm Dylan Watson. I love building useful software and thinking about better ways to get it into the hands of our users. So first of all, I'm going to start off with some guiding principles, things to think about in improving your path to prod. A little case study, recent project I've been working on, and some practical techniques that you can use to move your code into users' hands quickly and safely. Hopefully there's time for questions at the end, so I am definitely keen to get into some discussion if you guys have got thoughts. There's going to be some controversial stuff ahead. You won't agree with everything, I'm sure, but that's cool. As I said, we can have a chat afterwards. I will be keen to have a discussion. So first off, deploying software safely, it can be hard. Hopefully that isn't the controversial bit. I'm sure we've all experienced pain in deploying software, but it doesn't have to be that way. So I'm sure that we've all got a time when we've had a painful deployment to prod, maybe a late night or something. So I want you to think about what makes deployments hard. Does anyone have anything that they think, like what makes a deployment hard? Anyone have any ideas? Feel free to shout out. Doing it at 5 p.m. on Friday. Oh, yes. Late night deployments. Gotta love them. Anything else? Oh, testing? Yes, so manual testing is a huge one for sure. Yep. Anything else? Cabs, yes. Okay, so approvals and stuff like that, that's a huge one. So things I think about might be coordination between multiple teams, okay? Getting people to align is always really difficult. Scheduling out of hours deployments, I'd rather be at home with my family. Batching weeks and weeks of changes is super scary. You have no idea what you're sending into production, okay? Manual deployments, so any manual steps in your process to production really, that can make things really scary. They're likely to go wrong. You're going to mess something up, no matter how many times you've done it. And manual testing, discuss this as well. It's error prone. Okay, you want everything to be automated in your pipeline as much as possible. And once you actually get the thing into production, if something goes wrong and you can't roll back to a safe state easily, that's also really scary, right? So all these things build up this fear in our deployment process. Okay, on the other side of the coin, what makes deployments easy? Does anyone have any ideas? Sorry? Yes, yeah. So less changes going into production, right? Things like having your code always ready to deploy. So you've actually made all the automated checks before you get to production, before you even merge your code. No approvals, no coordination, Yes. Automated everything, basically, is probably going to be the pattern of this talk. But yeah, manual steps, testing, or approvals for sure. And you want to get to a point where your deployments rarely fail. But most of that is about practice and automation. So how do we do it? Okay, these are the things that I think are key when we're improving our deployment process. So first of all, we'll start off with, my talk's released here in a DevOps, right? So DevOps is really a mindset about automating or removing the steps in your process of deploying prod to production and being prepared to fail, right? So you're trying things out and experimenting with your deployment process and trying to just improve it. Back to fundamentals, basically what we're trying to do is write code, deploy it to production, get it into the hands of our users, right? That's ultimately what we're doing here. So we discussed before, small number of changes, less risk, right? So the smaller change that you make, you might have less risk of that failing, but also when it does fail, you know exactly what broke, right? You know that one little change that you made, that was the issue. You can roll it back, fix it, okay, it's isolated. You should only merge when it's safe for production. So this is more of a, again, this is like a mindset thing, and in order to check that, we'll go through the techniques and stuff, but we want to merge and have all the automated safety and know that this thing is as safe as possible to go to production before you even merge that code. Testing is built into the pipeline. Okay, that's absolutely critical. So automated testing, and there's, I could do a whole nother talk about the types of testing, but testing has to be built into the pipeline. Same with security. Okay, so that's just another aspect that we have to consider when we're so this is like your code scanning or vulnerability checking. All this sort of stuff needs to be automated and will stop you from going to production if these things break. And lastly, once you actually get your code into production, you need to observe what's happening, right? You need to know, so this is like your logging, so logging or metrics and all this sort of stuff. You need to know exactly what's going on in production so that when things do break, you can easily track down the issue and that you know that something is broken in the first place. Okay, so I just want to chat a little bit about a recent project I've been working on at Bank West. So this is a home loan system with, depending how you cut the numbers, about 20 different components, so APIs and apps, and around about 4 teams. So when we sort of started our DevOps journey, we were making about 5 deployments per month, okay, which is still not terrible, but there's also a few teams involved there. And we increased to 55 deployments per month at around about. So on a global scale, that's not a huge amount, but it made a big difference to us, right? That's an order of magnitude difference. So how do we do that, right? We were prepared to fail often, okay? Try things out. We would have the engineers in control of deployments, and our definition of done was in production. So experimenting and failing often, we made failure okay and even expected often when we're trying things out. And because of this, we tried lots of things. Failure was cheap, okay? But we also had the backing from our managers to push and improve and make these changes. And the expectation is that most of these experiments failed. But the ones that worked, they had a big impact. Okay, so I think probably the biggest one for me is that the engineers were in control of the deployments. So when we started, the people doing deployments, the ops, were a totally different team, right? They sat over there, and you would say, "Oh, I want a deployment, please," and you'd have to schedule it in. And in order to alleviate a lot of the pressure, we brought that person in. So we brought one of those ops people into our team, okay? And that made a huge difference for us because it meant that all the people in the team, we had all the skills in the team to deploy our code to production. From there, that person trained the rest of the team, and we were able to work together, engineers, like dev and ops, to essentially automate our pipeline to production. To a point where anyone in the team could, just click a button. So, essentially what's pretty common now, the build it, you build it, you run it concept. And lastly, I think the fact that our definition of done is in production, right? So you can't close the ticket that you're working on until that thing is in the hands of your users. And I think maybe it's a guilt thing, but I think or even just a visibility thing. If you don't close that particular task until it's in production, it doesn't get forgotten about, and you know that when cards start to pile up, there's sort of you can feel it here that like you need to get that into production. That's a whole bunch of features that your users are missing out on. Okay, so now I want to share some techniques. I now want to share some techniques that help to deploy regularly and safely. So first of all, we want to separate our deployments and our releases. We want to use feature toggles and a little thing called expand, rollout, contract, which is a really great technique. Some of you probably have used it without knowing the name, but basically all these things are about taking a considered, measured approach, okay, to our deployments. So yeah, deployments and releases. So first of all, more audience participation. Who dreads deployments? I suspect anyone that deploys less often than a month probably is having these thoughts. Okay, and what about who dreads releases? Okay. Have a little think. Now, who thinks I asked the same question twice? That's valid. Okay, but basically, I'm here to basically separate those two concepts. Okay, so first of all, we'll start with some definitions. So deployments are basically, in my eyes, moving your code into a production environment. Okay, ideally there's zero downtime, so you're using some sort of deployment strategy like green blue deploy or something like that. But ultimately there is no downtime in your system. And it should be a low risk to the business. It's a technical exercise. We're just moving some code into a production environment. Okay, and with automation, it should happen with minimal human interaction. It also shouldn't be affecting our users. Is a pretty critical one. There's zero downtime, but there shouldn't really be any impact to our users. On a release, on the other hand, now obviously we had some people that thought I was asking the same question. Deployments and releases. That's like they're pretty ambiguous terms. I think release is a pretty ambiguous term. It's used for all sorts of things. Generally, I'll probably use the word launch, right? So I'll go through in a sec, but a release or a launch is basically about launching new functionality to a user. And maybe you're only launching to some set of users, right? You're only activating the code for certain users. And the fact that we're separating deployments and releases allows us to prepare time for comms or train our users or let them know that something new is coming. Okay, it's not going to be like a new Facebook release and everyone goes, oh, it's totally changed. Okay, we don't want to end up in that situation. Okay, so who cares? Deployments, the team should care, right? The team doing the work is sending that code into production, and they care when things break. Okay, releases, we're trying to give the user new functionality, so the user should care. Okay, and I think that's what we should be thinking about when we're separating things. Okay, so anyway, how do we separate these two things? Basically, we're trying to deploy a bunch of times, and eventually release. So, okay, basically, there's a bunch of different ways that you can do it, but the biggest one, I'm sure a bunch of you will know, feature toggles are the way to do this, okay? So, for those that are unsure, this is a feature toggle, okay? It's essentially just something wrapping our code, an if block that says if this new feature is on for some specific user, and this thing could be entirely broken underneath. Ideally, it's not, but the block allows us to test out this new feature without affecting other users. So with feature toggles, we can deploy our changes and they will be inactive, okay? So they won't affect our users. They can be slowly rolled out to certain users, and basically they allow features to be merged and built out without affecting other teams as well. So other teams working on the same component, in the same area, aren't affected by your work, okay, your potentially broken new feature. The other dark side of this to toggles, some of you might have heard about the Knight Capital recently that basically forgot to clean up a particular toggle, and they reused the same toggle name, and it caused them to lose millions of dollars. So the critical part of using feature toggles is to clean them up afterwards. Okay, so my rule of thumb is basically once it's on and you've proven that it's not going to break, you then remove it. Right? It sounds obvious, but it's something that it's often gets forgotten about. But once you turn it on, you remove it. Okay, maybe a week or whatever, but you remove it almost straight away. So in terms of the process, we might introduce a new feature with, if this new feature is on for some internal user, so we turn it on for internal users to begin with, and we can start building out this feature. So we add some more new shiny feature, maybe a bug fix, okay, because our users have been using it, our internal users. We've been dog fooding this particular feature, and we fix some bugs, okay. After that, we start turning it on for some specific set of customers, okay. And maybe we make a few more bug fixes, but we're only affecting a small subset of users. And then finally, we turn it on for everyone, okay. As soon as that happens, we remove the code, remove the feature toggle, and everyone has the shiny new feature. So, okay, so that's about introducing new functionality. When we want to introduce, say, a new field or a new endpoint for our API, we use a technique called expand, rollout, contract. Okay, this allows us to make basically breaking changes in a considered manner. So expand, rollout, contract. I'll go through it in a sec. So some more code. Hopefully it's simple enough. But basically, we've got a user. They've got a name field, a surname field, and some usage of that field. So we think, well, actually the name field really should be first name. Okay, we want to rename this field. So the first thing to do is we expand. Okay, so we add our first name field. No one really uses it. We've added the field. We deploy that to prod. And then we want to start, we've got this new field, we want to start using it. So we make a change. Everyone starts to use this field, okay? There might be, if it's an API, there might be multiple other APIs consuming this particular field, okay? Everyone updates to use this new field. We deploy to prod. After that, so that's rolling out your change, right? After that, you want to start to contract. So once you've proven that everyone has stopped using that particular field, you then contract and you remove the now defunct unused field. Okay, so this is a measured form of deprecating a particular field. So we remove our name field that's no longer used, and we go about our lives after deploying, right? So yeah, expand, roll out, contract. So this technique is really useful for API changes. Okay, it might be fields, might be endpoints, but it's also really useful for database changes. You can do the same thing, and like library changes. Library changes potentially a bit harder to track down usages, but yeah, if you can understand your users of your library, then this works just perfectly. Okay, obviously, always deploy to prod. So, given everything now, what does an ideal deploy process look like? So we've got automated tests and security scanning. We've got an automated deployment process, okay, and it's really quick to roll back, and really quick to get it back into a safe state when things go wrong. Our changes are toggled, so when we deploy them, they have no user impact initially until we're ready, okay, until our users are ready, until we've tested that feature and we're happy. And that means that we minimize the number of approvals required after you've merged your code. You can have as much process as you want before you merge your code, as much as you need, but ideally, after you've merged that code, it should be ready to go to production, and it's all automated. And our changes are backwards compatible. Okay, we're using expand, roll out, contract, or some feature toggling mechanism, and so we minimize the coordination that we need between teams because we're not breaking other people. And we're doing this all the time, so it's proven. And our deployment failures are rare. They happen, but we have a rollback procedure, and everything works smoothly. Okay, so deploying at speed is not a leap of faith. Okay, you don't just throw stuff into production and just cross your fingers and hope, right? It's having that safety removes the fear. Okay, and that safety allows us to deploy at speed. That's it. Thank you. So I assume we've got heaps of time for questions.
Yeah.
So.
Yeah, thank you very much, Dylan. Now I'm going to open up the floor for a Q&A session. Has anyone got any questions for Dylan?
How do you prove?
Oh, we just got one down the back first, just for the mic.
I guess being sort of still new to developing or whatever, just wondering what these type of manual deployment processes kind of look like, if they're like that much of a pain.
What do manual deployment processes look like? I guess I don't know. It could look. It's different in every company. So I guess I'm thinking about maybe the old days where you're FTPing your files onto a PHP server or something, and then or like manually copying your WAR file onto a server that's like a pet server that you keep alive, specifically, and you don't create new ones all the time. Like it's not basically because that machine is set up by some person somewhere 5 years ago that has since left the company. So you're looking at setting up VMs via code, and basically all the pieces of infrastructure that you need are set up via code. That's the automated way. I know that's sort of very vague, but it is totally different in it depends what you're deploying.
Cool, thanks.
Yeah.
Next question.
I guess this depends a lot on if we're talking about client side or server side. But how do you prove that, in your expand contract, for example, how do you prove that, say, a property of an external API, is?
Yeah. So I guess
internal. I mean, within an organisation, but
so within an organisation, it's ideally much easier. So, like, there's plenty of tools out there. Like, ideally, your organisation's got some sort of code repository, and everyone can see that the usage of that code. You should be able to know the dependencies of each of the systems. So, I guess I'm thinking about client libraries. So, if you're talking between APIs, an API might output some sort of client library, and so know the people that depend on that client library, so you can check those usages. External is a much harder thing. It's essentially a library, right? So you have to deprecate fields and give comms to that, and wait a long time. that becomes a much harder deal. But internally, this stuff it shouldn't be hard. It is for all sorts of reasons, but it shouldn't be hard, and you can make great strides internally, at least. I think. I don't know. I feel like that was super vague, but yeah, there's definitely tools out there.
It was turned off. There we go.
There we go.
I was just going to expand on that question. So a few years ago, I had a bit of experience working with you. And
here we go.
It was an awesome experience. But I love the expand, rollout, contract. But adding to that question, we experimented with consumer-driven contract testing.
Yeah.
But it never really seemed to take hold. It never really seemed to work. And I was just wondering, where did it land? Did you get it working, or did you find other ways to...
So I have seen other implementations that worked, but we ended up ripping it out and going for, as I was sort of talking about before, having a client. So each API would spit out a client library, and for either back-end services, so like Java, or front-end as well. And the key to that is also that, we had a lot of issues early days where we would make backwards incompatible changes. So we would just sort of forget about consumers and break them, thinking that contract testing was going to help us. So we ended up writing, and there's plenty of tools out there that sort of check your swagger and fail your build when you make backwards incompatible changes. That's not to say that you can't make them, but you have to do it in a measured way. So you don't make them unless you have sort of proven and sort of gone through all your Git repos and checked that the other consumers are not using that field or that endpoint anymore. And that's usually just a case of a search. But yeah, first of all, you don't make those backwards incompatible changes by default, at least.
Cool, thank you.
Yeah, about feature toggling. So I've seen feature toggling fail terribly. Thankfully, not because of me, but of some people. And I was a very fortunate spectator about it. So I've seen it fail many times, even though I was perfectly capable of doing so also on my projects. My question is that, do you think feature toggling is more of an engineering thing than a DevOps thingy?
So I have DevOps in my talk title, but I think the concept of having it. So first of all, I think the concept of having DevOps as a role or something feels like it's defeating the purpose of DevOps. But I guess I think I've lost track of what I was thinking. Ask your question again. Sorry.
Do you think it's more of a DevOps thing or an engineering thing?
Yeah. Okay. So that's, I guess my thought is it should. There's no distinction for me. Engineers are the whole point of DevOps is that you've just got smart people doing like work, right? Ideally, right? So the point of DevOps is like that you're bringing in all these people and working together. So I mean, maybe it's not one person, maybe it's one team, but distinguishing between like actually having a specific role for DevOps doesn't make sense to me, because you're just a team of people working towards improving. Yeah, I don't
collective intelligence.
Really, yeah. Well, yeah.
Got some more questions?
Yeah, hey Dylan. My question is also about feature toggling. So I've seen, teams losing track of the toggles, not cleaning up. Did you have any kind of tooling in place, or also you kind of present it to maybe the business and look, that's in production. Now we turn it on and then we clean it up, because let's say 4 teams, 20 components.
Yeah.
You might lose
Yeah. So that was a big thing for us. So at Banquest we were using I would say like internal tools for the feature toggles and also managing them. But we definitely had visibility of what toggles each team owned, how long they'd been turned on, the state of them in each of our environments. So we had full visibility, and I don't know, it seems silly, but like if they got too old, they would go red, right? We would know that this thing is getting old. There was like it has to be a conscious decision to keep that thing around because it's like in your face. And like, that was all custom stuff, but like tools like Launch Darkly and stuff, which are the popular ones in the outside world, they have all this stuff. Like you can see how old toggles are, and we basically wouldn't start work or wouldn't be able to deliver our new feature until we'd gotten rid of the old feature toggles. So like, yeah, I mean that's a bit of process, but like you have to have that ability to something to audit, like removing stuff. Otherwise, it just gets forgotten about.
Well done, Dylan. You can have the speed up in your deployment. But as a consumer of the database, I did a lot of analytic and machine learning. And in your example, you changed the field name. That will break my code. How you make my life easy as well?
Yeah, right. So I guess that's why you're taking the measured approach of not renaming. So there's no such thing as a rename, basically. There's an add and a remove, but it's a considered step. So in the case of, say, a database, you would be adding a column and populating both columns, okay? And no one's using that other column. You would migrate the data into that other column, maybe as a second step. Only once both columns are sort of working in tandem, then you can switch over to actually using that new column. So then that would be at the point that you would start to use that new column. And once we've proven that you're actually using it, and so is everyone else, then we can drop the other column. That would be the approach.
Thank you.
For testing, when do you use a load balancer and to divert some of your traffic to the new feature and roll it out slowly rather than use feature request?
So that's, to be honest, not something I've really ever tried. I'm sure it's a valid approach, but most of the stuff that I have done is more about you would deploy. So that, I guess that's more about like what's it called, like basically shadowing requests to some sort of system before you take it and make it live.
Yeah.
But yeah, I don't have experience personally. Most of the things I do is like you actually deploy the thing into production, and the code is inactive. So you're not really having two versions running at once. You're just switching over, and then you can control, turn on some toggle or some toggle for specific users. Yeah, it's more about that. It's easier to reason about in my head.
So I guess it's pretty much down to the concept that we're deploying with a high level of frequency, which implies to me that we're more prone to put bugs into the production environment, although I understand that's probably with a smaller user base.
Yep.
How do you rationalize that? Like, is it just subjective? Do you go, oh, well, these users are prepared to cop it, so it's okay, or what's going on there?
Yeah, okay. So I totally get that. So we're releasing more often. More likely that code is less ready and getting into the hands of our users, right? So the key thing is that ideally so with feature toggles, you're exposing less of your users. So you're maybe only exposing your team initially, right? And I know that's hard depending on your system, because depending on your system, your users are, like your team is not really able to dog food your app, right? Particularly in the case of Bankwest, where my team wasn't applying for a home loan every week. But we've got other environments where we do that, right? Where we might turn on in that particular environment, we might turn on just for my team until we're really happy. So we're not even affecting other teams, we're just affecting my team. Okay, the team that's actually building out that functionality. It's definitely a risk, but I would trade it off with the fact that if you're bulking up, 2 months of changes and sending that into production, and that breaks, well, what went wrong? 2 months of work? I have to sift through 2 months of work to figure out what the hell went wrong. That's going to take me much longer than, say, that one thing that I send into production.
I guess just to add to that, so it seems like it is kind of subjective. We haven't necessarily been able to quantify doing this way has less impact than doing the other way. It just seems that way because we're not as stressed in the large releases or deployments.
Yeah, but yeah, I don't have no for sure. I don't have numbers, but I guess I guess I've definitely seen the alternative. So from my experience, I've seen deployments go wrong and go wrong catastrophically way more when you're deploying, monthly or whatever.
Yeah, so it seems like the impact will be less with a higher frequency of deployment, even if there are more bugs, they're not as damaging, so maybe it's okay.
And it's way less stress as a developer, which ideally also in turn makes for less bugs, but for sure, I don't have numbers.
No, thanks.
Oh, great. So I work at a bank. I work for Up, which is now owned by Bendigo. So we ship 6 to 10 times a day, but Bendigo might ship once every few months. Were there any things you had to do to bring the other teams within the bank along this journey to allow you to ship multiple times a day and release more frequently? Thinking like risk teams and those type of things.
Yeah, so that's definitely That's definitely a hard one, right? And I think what made it possible, at least at Bankwest, was the setup of the team. So again, when these things arise, say for deployments, we brought in our system engineers into the team. So actually having, like, bringing the critical people on the par, like critical expertise, bring them actually into our teams, even or our project sphere, whatever you want to call it. But actually bringing them in so their goals are your goals. It's not an easy problem for sure. There's a lot of different disciplines that need to be involved, but ideally where you can bring them in, and so you're both heading in that same direction. That's.
Is that something to do with your methodology as well, like being truly agile as well, and having that framework across the organisation to accept continuous development?
Yeah, I think that's like all this stuff is a constant. Well, you constantly hit up against these sort of problems, but also you're constantly trying to improve. And any organisation is not going to be homogenous, right? It's all different areas are going to be totally different and working in totally different ways. But I think if you can somehow align on like what you're trying to achieve, that's how you get that done.
Very good. All right. Well, thank you very much, Dylan.
Cool.
It was a great presentation. So how often does it?
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me. Okay.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking
God,
at
this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
We got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking
God,
at
this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd.
Right, hello everyone. Normally I'd like to be in the crowd a bit more, but I've been told because of the banner and the microphone I have to stay behind the lectern. I'm Karen Lowry. I'm talking about their people, not users. The only thing you really need to know about me for this talk is on the main slide, and that's I'm a graphic design lecturer. I currently teach sessionally at Murdoch University, teaching in the graphic design degree, so if you do have graduates come through that don't know what they're talking about, that's probably my fault. So I'm just going to give a shout out to all the sponsors that make today possible, as well as all the volunteers and the committee members who are giving their time to put together this great conference for us. So today what I want to talk about is human-centered design, and this is a term that's actually coined by Don Norman. Don Norman wrote a really great book called The Design of Everyday Things that I highly recommend. And he says the goal is to produce a great product, one that is successful and that customers love. It can be done. So this is all about empathy, which is something that we are familiar with many from UX design. And we're looking here at putting people first. We're looking past the visuals, but unlike what we see in UX design, we're actually also looking past the functionality to focus on the thoughts and the feelings of the people who are using your app and your product. So how do we do that? Well, most of the time we'd start with a persona. So let's meet Ben. Ben is a software developer here in Perth. He's married, he doesn't have any kids, he's got terrible taste in music, and he enjoys rock climbing and running as his two main hobbies. Once we've written our persona, we might make some scenarios. And chances are, once we've written those scenarios, the language that we use to talk about Ben changes. We might find we start using words like user, like visitor, click, subscriber, traffic, customer. The language goes on. These words are actually quite problematic because they focus themselves on the role of the user when they're using your product. We assign a role to them based on that interaction and based on how we intend to profit from them. Don Norman, who I mentioned coined the term human experience design, is actually the one who coined the term user experience design. And he developed what we call human-centered design because he also thought these words were quite problematic. Because Ben is none of those things. Ben's a person. So the first thing that we really need to be doing here is changing our terminology and calling our audience people. They're not users, they're not visitors, and they're not clicks. This is a really small change that we can be making in our internal documents in our company, but it actually allows us to refocus our team on what's important. And that's this big, messy, complicated experience that we call being human, and the fact that your app's only one small part of that. Because let's face it, being human is complicated. Just look at Ben. Ben screws up a lot. Do you really think you can account for all of the different ways Ben manages to screw up on an almost daily basis? Ben is lazy. Ben doesn't like having to get up in the mornings. He'll often leave for work at the last possible moment. He's unpredictable. Not even his wife can sometimes predict some of the behaviour that he manages and the decisions that he makes. He's very complex. Like most of us, Ben will often believe in contradictory things at the same time and get in very heated arguments about them. Ben also wastes a lot of time. He'll spend a lot of time on his phone browsing Reddit, a lot of time watching TV. When we use language like visitor, like user, we are suggesting that there's a such thing as an ideal user for our app. And there is no ideal user. That doesn't exist. We don't know the situation Ben's going to be in when he uses our app. We don't know the environment. We don't know how he's going to be thinking or feeling. So we really need to be thinking about how we can change this terminology and think of Ben as being human. Because if we don't do this, Ben's going to find our app really frustrating to use. And when Ben gets frustrated, when he does screw up, it's not Ben's fault. Ben's very good at blaming other people. It'll always be your fault as the designer. A way around this, as I tell my students when I'm teaching, is to ask why. You want to ask why 5 times is a guide that I give my students. And we do this because human error is never the answer. If the answer you've come up with is that it's Ben's fault, you have to keep digging because Ben will not accept the blame. You need to look beyond the feature that Ben's gotten stuck at and look at the problem with the system itself. Because Ben cares about a lot more than your product. So we need to look beyond the product itself, beyond the features that you've developed. Ben himself, he cares about climate change. He's quite concerned about the world. He's very aware, given he's a developer, about how his data is being used and about the kinds of permissions that he's granting the apps that he uses. Ben's much less likely to use your app if it's not ethical. Now, I'm going to put a little asterisk here because human-centered design doesn't have to be ethical, and we see plenty of examples that aren't. But human-centered design is about focusing on the experience and creating a positive experience for people using your app. So it should always be ethical. And when we're talking about ethics, what we're really talking about is the respect that you have for your users. People are more aware now than ever before, thanks to shows like The Social Dilemma on Netflix, about the social responsibility that people making their media should have. So the very first element we need to consider when we're talking about ethics is human rights, making sure that you protect the fundamental human rights that your app has. So we're looking here about your social responsibility at the very core. You want to make sure your app is transparent, accessible, and sustainable. So you don't want to deceive users. A really good example of this is the Twitter blue tick. When we see a blue tick on Twitter, we often see it as holding some kind of power. We see it as representing a status symbol of power and recognition. No one has really exemplified this more than the way people have reacted to Donald Trump on Twitter before he got banned. The blue tick actually just recognizes a high-profile user. It stops other people from impersonating them. That's all that does. But the decision that Twitter made to use a tick as a symbol very much changes the reaction we have as an audience to that symbol. We want to also be transparent in and upfront about the purchases people might need to make in our products. We've all heard of microtransactions. EA Games made the news a few years ago, 2018, 2017, over microtransactions. The microtransaction industry is still massive. In 2021, it was worth $60 billion. So there is definitely a lot of money to be made here. But is it ethical? EA Games had developed what they called loot boxes as a way to advance faster in their games. We saw Belgium in 2018 ban these loot boxes as a form of gambling. That actually got overturned briefly. And it got overturned because the actual legislation that defined what gambling is didn't cover this form of in-game purchases in apps. But while the law wasn't really up to speed, and still isn't in many countries, around our use of microtransactions, it doesn't make it ethical. Do we really want our kids and our teens in these apps, potentially with your credit card, making these purchases and learning from a really young age to gamble rather than putting in the effort for gameplay? Your product should also aim to reduce inequality, which is a really important aspect of human rights. This comes down to learnability, thinking about how easy it is for first-time users, and also that dreaded word that I'm sure we all find frustrated with at times, compatibility. Making sure it works backwards across different devices. Our next element is respecting human effort. So your app should be functional. It should also be trustworthy and reliable. You want to respect the effort that we're actually putting into using your app. So you want to respect privacy here. You want to only collect information from the people that are using your app that's absolutely necessary to be using it. We are more aware than ever, as I said, about the kinds of permissions that we're granting when we use apps. You also want to think about the extent to which you as a designer or a developer are actually going to influence the behavior of the people who use your app. A really good example of this comes from a book called Stolen Focus by Johann Hari. This book looks at the different ways that our attention spans have actually reduced. And it just looks at ways beyond just technology and beyond social media. But it does have, understandably, quite a few chapters about social media. And in it, Johann talks about the creator of the scroll feed, and says that the creator of the scroll feed actually deeply regretted his decision and being a part of this creation. And it did what it was supposed to. It kept people on the app, it kept people there for longer, allowing them to collect more data, sell more ads, and make more money. But it didn't respect effort that people were putting into being in that app. We compare this to Netflix. Netflix, after you've watched a few episodes, gives you a notification asking if you're still there. It is thanks to this notification that Ben makes it to bed on time at night. So the last aspect we've got is where we really see this link with human-centered design, and that's creating positive experiences. This is about the emotional connection people have with your product. It should be delightful, it should be intuitive, and it should be invisible. If your app works well, I shouldn't notice the interactions I'm having in it. It should be that easy to use. If I'm having to think about it, you've done something wrong. Now, we can't consider ethics without also considering the wider community, because Ben is part of a bigger community. Our design has to focus on the entire activity under consideration, not just the smaller components you have. And this is a reason why we all have terms like feature creep in our terminology. Ben is part of a much bigger system than your app. He's part of the software community here in WA and in Australia. We need to be sensitive to the history and the culture and the beliefs of the structures and the community that we're designing for. And you can't do this on your own. Even if you have a team of people whose job this is, you cannot do this on your own. You need to be talking to the community that are going to be involved in your app. Which means you can't just talk to Ben. Ben is very privileged. Ben is white and male. Ben has no ongoing health conditions. Ben's got a full-time job with a good salary. Ben has a bachelor degree. He's paid off his HECS debt, something I'm sure not many of us can say. And Ben is heterosexual and married. Being people-centred means you have to consider all of the people who are involved. If we use healthcare as an example, this means the patients, this means the doctors, the families, the general practitioners, specialists, technicians, nurses, the list goes on. You need to think about everybody in that community. Now, how do you actually do this? Well, there's obvious solutions with connecting with stakeholders, doing field interviews, setting up meetings, going out and observing in different industries, and this can be costly. I'd like to note here that it's not as costly as spending a year developing something that the community doesn't actually want. But you should also consider the ways you can use your current channels to be engaging in this process. For example, I always have an open communication channel that I invite stakeholders to. And I can really quickly and easily drop in issues that we're having, questions we might have, and keep the community on board with the progress we're making in the app and those decisions that we're making. So you could even be thinking about here, how can you repurpose the technology and the systems already available to you? That might mean making a dedicated channel on Teams, for example, where you can invite some key stakeholders. For me, this part of the process is really important, and I couldn't develop any work without having that open communication channel with the stakeholders involved. So simply put, we want to learn about the people that we're designing for, and then we want to take time to make sense of what we've learnt. And I've got this as a separate point because we don't want to come in with assumptions about who Ben is, because Ben's very unpredictable. He'll surprise us. We then want to look at opportunities for how we can improve people's lives, and we want to do so ethically. Only then should we start prototyping while maintaining contact with our community stakeholders. Now, if some of you have caught on, Ben is a real person. He's my husband, and he's in the front row here. So let's all thank Ben. Cool. I'm not sure how I'm going for time, if there's any time for questions. Yeah. Cool. And Ben is on just after me, by the way, in the main theatre, so that's Ben running off to get ready for his talk. Ben will be talking about offline mode, offline first, not offline mode, in the lecture theatre.
Great talk. Congratulations for Ben. Good sport. Any tips on how to affect change within an organisation on using inclusive language, people, when it's so ingrained in that culture?
Absolutely. So this can be probably the toughest one. I find so I write a lot of the reports myself, and I'll actually use inclusive language in the reports that I am making. So I very much try to push that from the point of view of the same as when I'm in the classroom, being the one that's making the change and setting that example. There's other solutions, such as actually getting community stakeholders in. So I find that while that can be quite costly, it can be really effective when people are being told about the importance of inclusive language from the people who are actually affected by it. Looking at healthcare as an example, bringing people in who actually suffer from disabilities and talking about the way some language impacts them can really change people's focus, because it stops it from being an abstract term. And that's the issue we have with language. These terms, they just feel really abstract. We don't connect them to people. When you're actually faced with the people you're using this terminology for, it can be enough to start pushing for that change.
Any other question? Thank you so much,
Well,
Karen.
thank you.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking
God,
at
this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
we got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
And I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey, Frank. friends. I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are.
Welcome, everyone. Our next speaker is Troy Gerwin. His talk is on the limits of my programming language, meaning the limits of my world. Troy is a software engineer with broad industrial experience, and he's currently developing games at VGW. He also maintains and contributes to several open source projects and is a mentor at Coda Dijo. Troy is interested in what makes software great, not just for the user, but also for the team maintaining it. A big welcome to Troy.
Thanks for that introduction. Thanks everyone for coming. And also, of course, thanks to the sponsors who've made this whole thing possible, and also the volunteers and the organisers. One other thing to remember about DDD is that it's a democracy, and that's a cool thing, right? But you know what the problem is with democracy? Sometimes candidates make promises to get voted in, and then they find that they can't deliver on their promises. So when DDD called for submissions, I was just thinking, like, what would be a cool talk? What would be something interesting to go to? And I just sort of thought of this, there was a phrase that was popping up, and I Googled it and I found, okay, it was this phrase by Wittgenstein, a philosopher. And he said, the limits of my language mean the limits of my world. And I thought, wow, that'd be an interesting thing to think about with programming languages. Like, are we actually stopping ourselves from doing a better job as a software industry because of limits in our programming language, not being able to come up with better solutions or less buggy solutions? So I just shoved one word in there and I thought, okay, that's a nice catchy title. All I need to do now is come up with a pitch, and here's like a little summarized version if you don't remember it. But I'm just saying, like, you know, badly designed programming languages, thought inhibitors? Are they part of the reason why we ship projects late and with flaws? So that's as far as I went, unfortunately. I delivered the promise, but I didn't actually stop to think of what it would take to actually fulfill the promise. So when my talk actually got selected, I started to think about what the content would be for this talk, and I thought, oh crap. Anyway, it's too late to change the pitch at that point, and I didn't want to do a bait and switch because there's a lot of depth and a lot of breadth to this topic, it turns out. So I could either just fly over the landscape and not really give much detail anywhere, or I could deep dive into one thing, but then I really feel like I'd be breaking my promise, which was to sort of cover it a bit more broadly. In early feedback, I gave this talk earlier, a draft version of this, and I got some really cool feedback, and someone said, this talk title could be the title of a whole tech conference. You could have a whole tech conference about this, and then people would go to the individual talks and focus on the different areas. And I thought, oh, that's a cool idea. And it actually gave me a way of thinking about what this talk that you've come to would be. This talk would be the keynote. So imagine that we've got a whole day to talk about this topic, and this talk then just means I can just kind of like go at 10,000 meters over the landscape and just maybe point out a few little details here and there, knowing that, you know, that's something that you can follow up in detail in another area. All I can do is really just give it 5 minutes and just cover a whole lot of things. So just at this high level, we're talking about programming languages, and I thought that this is a quote from a really great introductory textbook on functional programming by a couple of guys who are really influential in the ML community and developing Camel in particular. And they said, the programming language we use influences our capacity as programmers to produce correct programs within a reasonable period of time. And something implied in this, we're not talking about, there's no problem with being able to express solutions. We can express solutions. Most of you have probably heard of Turing completeness. It just means if something's Turing complete, you can compute absolutely anything that is computable with that device or that language or whatever it is. And it's actually a surprisingly low bar. Redstone blocks in Minecraft are Turing complete. Excel spreadsheets are Turing complete. I just found out at a previous talk I went to that PowerPoint slides are Turing complete. You could build your line of business application as a deck of PowerPoint slides if you really wanted to. But we don't do that because the two real key things are not can you build it, it's that can you build it in a reasonable period of time and with few enough defects. So these are the two really important things. So just to summarize those two things, I've just used the words convenience and correctness. So these are kind of like the themes that will come back again and again. The pictures, you might be wondering what that's all about. I went to another conference the other day that my work put on, and I just heard this phrase, dragons and rabbit holes, and I thought, hey, that kind of applies. So dragons are like on the edge of the map, there'd be dragons, right? They're the things you want to avoid, the bugs, the undefined behavior in your program. So that's correctness. Rabbit holes is when, in the context of programming languages, it's really difficult to figure out how do I express the problem that I'm trying to solve in the language. The language, maybe it gives you no clear ways to do it and you've got to build up all this stuff yourself, or you're out there searching through half a dozen libraries that give you different trade-offs and so on. So convenience is about how, what's a reasonable amount of time to be able to come up with a good solution, and how maintainable is that solution. So these are the two sort of overarching themes that we come across. Just to briefly go on those, actually, I think for time I won't go into details, but some of you may have heard of the Sapir-Whorf hypothesis. So convenience is really about this idea that limits in what language what your language can express mean, limits in what you can actually do. So it's language as a thought tool. It can basically multiply your powers, or it could divide your powers. So this is the effort to express requirements as a program using a programming language. So the general thing with convenience is that we seem to be suggesting that we want more flexibility and we want rich language because that's going to make it more convenient. On the other side, correctness, the safety of being able to express things in a program. The set of possible programs that exist out there is huge, right? Probably infinite, definitely infinite. But a lot of those programs that we could possibly express, they're subtly wrong. They might be almost the right solution, but not quite, but we can still express them. So this sort of implies that we want less expressiveness. We want to basically cut off avenues towards expressing programs that are wrong, that are subtly wrong. For example, some programming languages allow you to express memory management explicitly, but they introduce the dangers because of that, because they allow you to express all the incorrect patterns of memory management as well. On the other hand, you've got languages like Java or C# that have automatic memory management. You cannot express memory management patterns. It doesn't let you do it. It just does it automatically. So it's less expressive, but it's more correct. So if this was a fictional conference, PLConf 22, this would be the billing of the talks. So I'm going to talk just briefly about a bunch of topics here, basically some fundamentals at the beginning. This general theme that I want to bring out, that programming languages are for humans, and then a couple of deep dives at the end. All right, getting started on the first one. Just about motivation. Why would we care about programming language design? Does it really matter in the real world? So Mark Andreessen, about 10 years ago, put out an article that was quite well known, Wall Street Journal, Software is Eating the World, and he was just pointing out how we've just got this unprecedented and growing global dependence on software systems. Just look at the companies that I've listed there, think about how they've transformed our economy. So bookshops, Amazon comes along, the global book industry is now basically a software industry. Uber doesn't have taxis, they don't have their own drivers. They have an app and they have a bunch of software running on the back end, and that's the global company. So more and more of the global economy is actually software. It's built and runs off software. So this also implies that there's these growing and huge risk and reward multipliers because so much of our economic everyday activity is mediated through software. So if you can increase the convenience of being able to create that software more quickly or more reliably, you might have a great competitive advantage. Equally, if you can improve the correctness because of new patterns in programming languages that just block off avenues of expressing bugs, you might experience less hacks, less exploits, and less failures, which is also going to be good. So I'm not suggesting that programming languages are the only problem for improving our productivity with software. They're probably not even the major factor because we've got people and we've got processes, and that's usually where you look if you want to make things more efficient. But I don't think it's zero. I think that what I'd like to demonstrate today is that programming languages themselves can shift the needle on things that are actually important in the real world. And even if it's a small amount, we're talking a huge numbers here, right? So it's still a huge number. So the question is, what about these numbers? Like, are we doing fine as a software industry, or aren't we? So it's not hard to actually just like trawl the internet and look for examples, look for studies. I just listed a whole bunch here. I'm not going to go through all of these, but just so you can see the general size of the numbers. So the capital T is trillion. There's studies there that are just estimating the costs of software failures in the US alone at something like $2 trillion a year, which is like 10% of the economy. Even if their estimates are way off, even if they're vaguely in the ballpark, we're talking really huge numbers. There's lots of other things there that are easy to find if you're interested. There's also really interesting individual examples, and I'll just highlight this Therac 25. Back in the 80s, it was a medical device, I believe, for taking x-rays of patients. And injuries and deaths were involved. So that was a combined hardware-software system that they wrote their own software for that system, the company that released it. It had preemptive multitasking. It was basically written in assembly language, and it also had mutable shared state. So the language they were using didn't protect against any of those things. It was all up to the programmers to be able to spot their own errors. And in all their test suites, everything worked fine because they tested it in test conditions, had no problems. Eventually, they actually injured and killed a number of people because certain operators using that machine typed a bit too fast at the wrong time, and that triggered a race condition in their code. And they didn't admit it for a long time because they couldn't reproduce it, but that was definitely an issue that could be resolved with a different choice of programming language. So that's just one example, and there's others there as well. It's also easy to come across articles like this. So Microsoft did an internal study and found that 70% of their security bugs are memory safety issues. And in that article, they particularly highlight that a lot of the software involved is written in C and C++. Memory unsafe languages where one slip up in the developer's memory management code can lead to a slew of memory safety errors that attackers can exploit with dangerous and intrusive consequences. So that's really sheeting home consequences directly to the programming language choice itself. So just to sum up that section, programming language design definitely does have real-world consequences. Okay, another one of these topics that we would fly over in this conference would be that there's never going to be one programming language to rule them all. It'd be nice, right? But, well, here's a picture of each of those little words. It doesn't matter, they're too small to read, but they're all names of programming languages. And the little lines between them basically trace influence, and we're going down the page, so we're back in the 70s up the top, and we're down to a few years ago at the bottom. Anyway, I don't know about you, but I don't really see much sense of convergence in here. And also, it seems like ideas have been around for a long time, and they influence, they go away, they come back. So consensus in programming languages doesn't seem to really be there. So why is that? It's not for lack of trying. So the current candidate for the one programming language to rule them all, in many people's view, is JavaScript. And Atwood even made a law about, well, what he claimed, to be a law, that anything that can be written in JavaScript will eventually be written in JavaScript. And on the far side, on the right-hand side there, it probably too small to read, but it just gives you a glimpse. This is the TC39 committee that decides what things are going to make it into the next version of JavaScript. And pretty much this is like a third of just what fits on a screen. It goes down, and these are only stage 1 proposals. They also have stage 0, stage 1, 2, 3, and then 4 means it's in the language. So basically, everybody is trying to get the language to do their thing. So, it's not like we don't want there to be one language to rule them all. This is not new. So Tony Hoare, who gave us Quicksort, he also gave us nulls, the billion-dollar mistake. A quote from a paper that he wrote, he says, "We were charged with the standardization of a language to end all languages, designed to meet the needs of all computer applications, both commercial and scientific." And that was in the 1960s in reference to PLI, which most of you, including me, have probably never even seen, let alone worked on. So I guess that didn't work out either. The problem really comes down to the fact that there's competing goals in programming language design. So I'm not going to go through all of these, but just to give you an idea, there's just some I just hammered out. Just to, I think a lot of them would make sense, but I'll give you one illustration. So going back to this example with memory safety, that's relevant here. So some trade-offs here. So for example, if you had a fresh new application you need to develop and you're trying to choose which language to use, if you had absolute real-time performance requirements where you cannot stand garbage collection pauses, let's say, so you're on the side of having to have absolute performance, there is a trade-off there in the sense that you probably wouldn't want to use Java and C# because they do automatic memory management at the cost of some stuttering, some pauses, and just unpredictable performance. So you would probably want to go on the C++ or Rust side because you can actually literally control the memory management in the programming language itself. On the other hand, is there a trade-off, let's say, at the bottom between Java and Rust? So if we choose Rust because it's really safe with memory, why wouldn't we always choose Rust? Well, maybe performance isn't the top thing. Maybe it's just speed of development. And I'm not a super proficient Rust developer, but having looked around, I can see that a lot of people say it's not that straightforward to satisfy the borrow checker. You've got to really understand what you're doing in a non-trivial application. So why would you even put that barrier in front of your team of software developers if absolute real-time performance wasn't an issue? Maybe you're just developing a simple app for your own use, or I don't know, there's lots of situations where you might not have that requirement. So there's a trade-off there. It's harder to get the thing up and running and shipped in Rust than it would be in Java and C#. So it really depends on whether you have that performance requirement or not. So that's just some examples of trade-offs. Okay, moving on. This section would be about essential and accidental complexity. So this concept came from Fred Brooks, who gave us the book, The Mythical Man Month. So back in the 80s, he also wrote this paper called No Silver Bullet. And he gave us this nice way of thinking about software systems as having two kinds of complexity in them, essential complexity and accidental complexity. So essential complexity in software is basically the stuff you can't get rid of because it's the spec. It's like, here's the spec. Please go and implement a program that does this, that does what it says. So if it's in the spec and the spec's complicated, that's essential complexity. If it says you've got to do those 25 things, you've got to do those 25 things. If it says you have to interface with 3 wildly incompatible, terribly written external systems, that's an essential thing because that's what's in the spec, right? So you can't avoid it. Accidental complexity, on the other hand, is stuff that still makes it difficult and complex. They're just basically unhelpful barriers to expressing a working solution, but they're not inherent in the spec. So, for example, manual memory management. If you're thinking about managing your memory, but the spec just says, well, we need this mobile app for the customer, that's accidental complexity. It's just something you have to do on top of solving the essential problem. And choosing different tools can affect how much accidental complexity makes up the overall complexity of your job. So essential complexity sounds like something you can't get rid of. I just wanted to briefly mention that it's not actually true. You can reduce essential complexity, but with another trade-off. So if you think about domain-specific languages or even visual programming languages, they tend to be reduce essential complexity by allowing you to state things at a higher level. You can quickly say how you want things to be done. So for example, SQL for data access. So we don't write Python generally for doing database queries on a relational database. We write SQL and it's really quick and it gets the job done. But it's basically a domain-specific language or a DSL for that one job. So it sacrifices generality, but it means you can do that one job well. So that's great. There's languages that do things. Regex would be another example. There's lots of them. But they don't solve the general problem. It's not like if you're given a brief that you've got to develop a whole app, you go for the specific DSL. There probably isn't one in most cases. You need a general language, so you can't always make this trade-off. On the other hand, accidental complexity. So we still, there's things like boilerplate code. If you're writing your app, if you have to think about managing memory yourself or managing concurrency, managing dependencies, managing versions, these aren't things that are in the spec. They're just things that you've got to get right, and they're just unhelpful barriers that get in your way. Brooks in No Silver Bullet, interestingly, says, we've already solved the accidental complexity problem for the most part. That was his view back in the 1980s. I don't know if any of you can think of what he said was the #1 thing that made the biggest difference in solving accidental complexity. So the thing that made the biggest difference was, in his view, high-level language. So high-level language just means, now, this is something we completely take for granted. When you write program code in any programming language that we use today, pretty much, you are writing code using, for example, English keywords. It's human understandable. It's written in a high level. You can kind of see the loops and the conditions in the code. And it's translated down to something that the machine can understand. So that's what we mean by high-level language. It's that the code is independent of the machine that is going to run it. The specific things the machine has to do, they're not represented there in the language. That's high-level language. He estimates that gave us a 5 times productivity boost. So I thought it would be interesting, rather than just, 5 times, what does that mean? We don't really think about it, right? But I'd like us to actually think what it was like for our compatriots, software developers back in the day, before high-level languages, just to give you an idea of how important accidental complexity can actually be. So what were they doing? Well, first example, this is something that I personally remember, because I had a Commodore 64 when I was a kid, and no money. So rather than being able to go and buy all the cool games off the shelf, sometimes we'd come across a magazine and it would say, type the game in yourself. So it just sounds awesome when you're a kid, when you read the description, Space Blaster, this is going to be so awesome, like it's action-packed and everything like that. But then you've got to write this out yourself. And you can see there's a few lines of BASIC at the top, that's bootstrapping, but pretty much the whole game is actually in machine language for the 6502 CPU inside the Commodore 64. And you have to specify it byte by byte as these hex codes. The other thing is, if you get any of those wrong, if you get one letter wrong, one character wrong in any of that, well, if you're lucky, you've probably just screwed up a sprite and it's the colours are mixed up in somewhere. But more likely, most of that will be control flow and logic for the game. And if you just basically change a byte there, all bets are off. You probably crash your machine, lock it up, or who knows, it probably won't be the fun Space Blaster experience you're hoping for. Going back even before that, they had even extra steps. They'd fill out these punched cards. So I won't go too much into that. That's really going back. But I think you get the idea that there was a lot of accidental complexity involved in developing software back then. You've got to think at a really low level. The other thing is there's pretty much no protection from errors, because there's no interpretation step. What you present to the computer, it goes, well, this must be what you meant. I'll just try and execute it. So basically, I like to think of that as a cosmic ray on your punch card just gives you a new program. As far as the computer's concerned, oh, okay, every program that you give me is what I think you meant, and it just executes differently. So a little taste of that. 6502, this was the CPU inside the Commodore 64 and also the Apple II. I've got like 6 bytes of machine code at the top there, and that decompiles into these assembly language instructions. It's just a little loop. It just starts at 255 and it counts down to 0, and then it returns. So that's all it does. What I'm going to do is, on that last byte, I'm just going to change the 60 to a 61. It's 1 bit. It's just changing 1 bit. So watch down the bottom. And now, instead of returning from the instruction, I'm doing some further arithmetic and I'm not returning. And whatever comes after that is what the process is going to keep doing. That's a good example. That's probably just going to lock up your machine. I had to restart my computer a lot of times. Just another example. So now I'm just going to transpose the 2 parts of the 3rd byte. So instead of CA, it's going to be AC. And we can watch down the bottom again. And now I've got pretty much a completely different program. There's now no loop at all. And it also still doesn't return, so you're going to get a vastly different outcome. And I just changed a couple of bits. The program looks the same. So that's all accidental complexity. Just a bonus question to end this section. Can anyone think of any language that we still use very commonly, probably most software developers in this room have used at some point, that has some of these characteristics that I've just been describing? Yeah? Yes, exactly, regex. I like to call it a write-only language. See if you can think of what this regex does. I won't call for volunteers, but I'll just tell you it actually parses or validates email addresses. That's not obvious from looking at it. So the way you would come up with that is you'd think at a high level, okay, what are the parts of an email address? And you translate it down into this kind of almost like machine language. And then if you ever try and want to know what that does again, I would probably just copy it and paste it into one of those websites that sort of decompiles a regex for you and gives you a visualization. It's not that different from what they were doing back in the day. So yeah, we still have this. Okay, moving on again. Now we move into this section where I'm really focusing on the human aspect of programming language design. We don't want to overburden the human. Why is that? Well, I'm just going to start with this quote from Donald Knuth. He's pointing out that programming is the art of telling another human being what one wants the computer to do. Programming languages aren't for the machine, they're for people. If programming languages were for the machine, we'd still be programming in assembly language or machine language, because that's the easiest thing for the machine to process. The reason why we use these high-level languages and then all these very sophisticated tools to translate that down to the machine is that the source code of programs is for us, it's for humans. So if you think about what's scarce in the production of software, it's definitely not making more copies of it. It's free to make more copies of software. Like all the raw materials of what we use, RAM in memory, CPU cycles, like they're really cheap, right? The marginal cost of that is almost zero. So why is software expensive? And why, we talked before about the trillions of dollars worth of, the cost of software bugs. What makes up the expense? Well, I'd say it's actually human ability. So humans, we've got limited working memory, limited cognitive powers, and limited reliability. This kind of links back to the keynote this morning when we're talking about fallibility of human memory in particular. So that's just one of these things. And programming languages that adapt for that can actually really empower us. Ones that ignore the humanness and we'll see some examples anyway. They're probably the ones where it's going to be harder to express a correct program and increase your rate of bugs. So how could the programming language itself, how could the design of it actually help with this sort of human focus on the programming language, particularly humans being limited? So I've just got a whole bunch of examples there. I just bolded a couple that I could just briefly speak to, like raising the level of abstraction to reduce the semantic gap. So we saw before, literally putting in the hex codes, you can't really look at that and see what the program does, although I did do an early version of this, and someone who saw the Commodore 64 stuff says, I know what that does, because he had one and he still remembers all the opcodes. But for most of us, if you see source code, you want to see something that is kind of human readable. For most of us in here, that's things like, the English keywords and visual breakdown of blocks in the code. And I put that one there, visuality. Use layout and keywords and punctuation to actually make, we can recognize patterns visually very, very quickly. So if your source code actually allows for that pattern recognition of humans by having visually indented and delimited blocks, we can see that very, very quickly. That works with us. It helps us to produce software faster and with less mistakes. And also, what we really want to optimize in our code is understandability. Not necessarily making source code as short as possible, having a language that is the shortest to express, or the most minimal language, like the one with the fewest constructs. That doesn't necessarily win if it comes at the expense of human understandability. So just one quick example for this section. I'd say most of us are pretty familiar with basic control flow constructs like this. So control flow is basically just, it's an imperative concept for imperative languages, which are the ones I'd say most of us use, like Java, C#, things like that. You do things in order. There's a time-based component. I do step 1, then I do step 2. And if that's all you could do, step 1, 2, 3, you could only write a linear logic program and it would always terminate depending on how long, just basically how many lines you've got. If you want things that run forever, or run indefinitely, let's say, probably you don't want an infinite loop, you need control flow constructs that can alter the order in which statements are executed. And these really common ones, the top two are loops, so you can keep repeating the same series of instructions while some condition is true, or you could loop over every item in a collection. So they're really common. And then the bottom two are conditionals. So it's like just conditionally execute these things if a certain condition is true, otherwise skip them. Or look at this value and then, depending on what it is, either do this or do this or do this. So that's like a switch statement. Pretty basic, like, I think we're all familiar with that. But what if I told you we could go even simpler? What if I told you that a single control flow construct could do everything all those others do, and we can just sweep them away and make our language even simpler with just one kind of control flow? Well, it exists. If condition, go to label. So it just means that you should be able to label any line in your code, and then you can say, well, if this condition is true when you execute this line, just jump to that other label. So I thought I'd give a demonstration to show how great this would be. I picked a modern language that actually still allows GoTo, so I was actually able to test it, and this is working code. So I've started with a prime generator that's pretty straightforward. It basically just goes through all the numbers from 1 to 100, and then for that number, it does an inner loop to try and find something that divides into it, that excludes it from being a prime. So if it gets through that inner loop and it hasn't found any divisors, then it's still a prime, and then we just print it to the console, and that's what it prints out, 1, 2, 3, 5, 7, and so on, up to 97. So I just chose that example because it's relatively simple, but it's got loops and it's got conditionals in it. Now I'm going to transform it using my awesome one only control flow construct if condition GoTo label. So first of all, I get rid of the outer for loop, and I've replaced that. I needed a couple of labels and a couple of new GoTo statements, but it's the same program, still works the same. This is all valid C#. Then I get rid of the inner for loop, then I get rid of the first if, and then I get rid of the second if. And now I've got a final program that does exactly the same thing as the first one, but it's way simpler because it's only got one control flow construct. And also, we got rid of all that weird indenting, and now it's all nice and straight. So there's my before and there's my after. Okay, it's slightly longer. What would you choose in terms of, I mean, we're talking here about limited human cognitive ability, right? Maybe it's just my training, but I would take the one on the left still, even though you could say it's more complex because it's got more different constructs. So it's not about minimality sometimes. It's about working with the human, the way we think. I can visually see the loops in this one. On that one, I would basically have to run it in my head. So if you look for pictures of GoTo, people doing GoTo programming, you often find these screenshots that they've done of some old bit of working out where they'd obviously drawn all over the program source code to try and get it into their head what's actually going on. So on the left, we've just got these. You can express any control flow with these three constructs: sequence, selection, repetition. On the right, you can just use one control flow construct, but it's actually a lot harder to understand. Okay. So that's probably a good segue into this one, which is also about the humanity, the human side of programming languages and how to take it into account. So before we were saying don't overburden the human. Now we're saying don't rely on the human, because even if you make it easy for them, humans are fallible. We make mistakes. So the main point I want to make in this section briefly is that if a programming task could be described as a set of mechanical transforms, then design the programming language itself to just fully automate that. Just take it out of the hands of the human, because we're not that good at perfectly reproducing the same transformation again and again in a manual way. I call this the human compiler anti-pattern. So I don't think you'll find that on Google because I just made it up. But the reason I call it the human compiler anti-pattern, because I'm thinking that, people even get proud of doing this stuff. It's like, wow, I can really reliably create this really complicated code. But actually, what they are doing could be automated by the programming language tools themselves. That's great for this hotshot, whoever they are. That's really awesome for their self-esteem and so on. But statistically speaking, as an industry, it's going to increase our error rates if we require humans to do that sort of stuff. So let's have a quick look at an example that I set up. This is JavaScript. And I've just got a function here that, as it says at the top, it returns the number of files in a given directory. So it's a function. I pass it in a directory path. And at the end, it's going to return me a number, which is how many files, not directories, but files in there. And the way it works is by making a couple of system calls. One is to get a list of all the files in the directory, and it just gives the short names of the files, not the full paths. So then we have to map them to full paths, and then we can go and make another series of system calls, one per file, and get the stats. And the stats will tell us if it's a file or a directory, and then we've got all the information we need to count up the files in the directory. So I think that's pretty straightforward, and I just wanted to highlight that this is an async function, and we use await. I don't want to go into all the ins and outs in that. I'm hoping that enough of you understand a bit about asynchronous programming to just, if you came into JavaScript or another language with async await in the last, say, 5 years, I think that's hopefully fairly easy to understand. But async await is another one of these things that is an innovation that wasn't always around. What came before async await? What was being required of the programmer before it sort of took care of these concurrency patterns for us? Well, when I first started using Node, it was on the 0.x version number. JavaScript, it was always running on JavaScript on V8, but JavaScript at the time didn't have a sync await. It didn't even have promises. So if you wanted to do asynchronous operations, and Node has always been fully asynchronous from day one, you basically say, go and start this job, like go and get the file stats for me, and when you're done, call this callback that I'm going to give you now. So it's all callback based. It's basically continuation passing. So I've got, the next slide is this exact same program that you would have to write manually. It's the same program. You would have to write this out manually and manage all the callbacks yourself. There's a bunch of them up there. So you ask for a callback, and then you call that callback when you've either got an error. Well, actually, there's all the error pathways. So there's several ways that you could get errors at different points. You've now got to manually do all that bookkeeping. And if you get that wrong, you might just swallow the error, or you might just actually return several errors. Like a basic thing about functions is that if you call it once, it's either going to return or it's going to throw an exception, right? The only exception to that is like an infinite loop, but we won't go into that. Here, you've actually got the erroneous possibilities of calling the callback, which is the equivalent of returning from the function, and sending back multiple errors or multiple returns, or even sending back errors and return values at the same time. There's so many ways that this could go wrong. But people, and I remember, coming across Reddit threads with like, it's not that hard, like I'm really good at it, I've never made any mistakes. Yeah, sure. However, this is really just going to, statistically speaking, on average, that's really going to reduce error rates across the board, right? So if the compiler can do it, it should do it for you. That does sort of raise the question of design patterns, because they sort of meet that thing of really mechanical transforms on code to handle certain situations that you can always apply reliably, right? So I'm not saying that they're all bad, but I think it's interesting to look at some of the design patterns, and they're written for specific languages. Some design patterns you really don't need to code in a special way, depending on which language it's in. And it's an interesting framework to look at design patterns, that they're not always a great idea. They might actually be telling you that your programming language itself is not expressive enough, because you've got to do this sort of manual transformation to get that kind of code to work. That's a talk for another time. So moving on, making invalid states unrepresentable. Now, this is the section that I would want to do the full talk on, because this is my jam. What I really want to talk about here is type systems. Unfortunately, I've probably got about 5 minutes to cover this section. And to motivate this, like, why would we care about type systems? How does that fit into this whole thing of programming language limitations and so on? Well, this chart kind of says it all. So on this chart, we've got these bars that get bigger to the right. The bigger the bar, the higher the cost to repair a defect in software. And the further to the right you go, it means the later the bug was discovered. So that really tall bar on the right is bugs that were discovered in production. So you've crafted your piece of software, it's gone through all your QA, it's gone out to customers, and at that point, the bug is discovered. If you're lucky, the bug was discovered by your customers, and only hopefully a few of them, and you might have to make them whole, and that might cost some money. If you're unlucky, it might affect all your customers catastrophically with whatever, financial losses. If you're even more unlucky, it's not the customers that are affected, it's you that's affected because someone has found a vulnerability in your code and they've found a way to hack the system and cause all kinds of other damage, like stealing information about your customers. That can be extremely costly. So that's, I think, the sort of rationale for why there's this pattern of raising costs the further out you go. Catching it earlier means catching it in, say, QC. But if you've got, say, a big team of human QC testers, there's a cost involved in having that team, right? So it's quite costly to be using that team. If there's whole classes of bugs that you could find before it even leaves your laptop where you're making the software, it's even cheaper, because it never goes through those later steps, right? So this is a time when it's really cheap to catch bugs. The cheapest time is when you just catch things that are wrong in the spec before you even write code. But we're talking about programming languages. So let's assume the spec is correct. What can the programming language do to actually help you catch bugs before they even go out to production, because it's a lot cheaper to catch them there? And that's where type systems come in. By the way, this graph really motivates this concept of shift left. The idea of shift left testing is basically looking at this graph and saying, with all these defects and bugs, we want to shift to the left and catch them way earlier, because it saves us a lot of trouble, money and time. So there's a very, very strong link between, most people think of shift left as having better unit tests, but I think there's a really strong link between the idea of shift left, which is great, and static type checking, because type checks are tests. They're tests that you don't have to write as separate unit tests, but they will catch bugs for you before you even run the code. So good would be that you run some sort of build tool and it tells you, so I'm looking at the top of the screen here, and it says, hey, there's these errors in your code. And you can't take it any further. You can't run that program, you can't release it to production, you can't merge it to main. That's great. Even better would be the middle one, where as you're just typing in your IDE, it's already putting up a red squiggle and saying, hey, this isn't right. So just as you're typing, you're already learning that there's a bug and you fix it straight away. Super easy and cheap. Even better than that is before you've even typed something, it tells you what the options are. So a lot of these powers are actually driven by static type systems. All of this IntelliSense in the bottom, it knows what the valid options are because of the type system that your programming language has built into it most of the time. So these are really powerful things. And type systems are getting really good. So I think most of us are familiar with the old classics, classes, interfaces, and then basic types like numbers and strings and booleans. But if you look out there at all the programming languages that are being developed between research languages, functional languages, there's a lot of languages out there, and there's a lot of types. Some of them are actually not new, like sum and product types have been around for decades in functional languages. Others are, like at the bottom, they're linear types and affine types. Don't even ask me what that last one is. Yeah, they can get pretty tricky, and but there's a richness out there now. So if you want to learn about some of those things, like me, putting on a talk where I feel like I should have some sort of authority about it, you can just go to YouTube and start Googling making illegal states unrepresentable, and there's a whole bunch of videos, and they'll often be talking about type system solutions to this problem of, making illegal states unrepresentable basically means the type system should pick up errors straight away if you've specified, I don't know, user first name, middle name, last name, first and last name are required, middle name is optional. If you can say in the type system that intent and you can see it in the code, then you'll catch that error straight away. If nulls are just implicit in all strings, then you can't specify that intent in the code and you can't catch that error until you write a unit test for it or it goes out to production and crashes. So that's what we're really talking about, making illegal states unrepresentable. It's a type system thing usually. It can go pretty far. So in my wanderings, I came across this video and I thought, oh, there's a typo in the video name. And then I actually started watching the video. By the way, ATS is a research functional language that implements linear types, and they can do amazing things. But the guy says in the first sentence of his talk, he says, by the way, that's not a typo. I actually meant to say a tase of ATS. Like he said, it's so difficult to get right that it's like being tased. So, types, there's a trade-off. Again, there's a trade-off. They can be really super powerful, but they also mean, you might add complexity to the development process along the way. That brings us to TypeScript, which is a language I really love. TypeScript is basically making a lot of these advanced types go mainstream because they set as a design goal to statically identify constructs that are likely to be errors in code that already existed in massive quantities. JavaScript is already out there. Lots of libraries were already out there. They said, how could we actually analyze code that already exists, that people are already writing with all sorts of patterns, and add this layer over the top of that, a type system. It's a superset of JavaScript that can actually detect where there's errors in the code. There's the low-hanging fruit, like just spotting typos in property names. That's pretty easy, right? But as the project has evolved and matured, they've added some amazing abilities. We're at the point now in TypeScript where it's probably easier to think of the type system as itself a separate programming language. As a programming language, I would describe it as a DSL, or a domain-specific language. It's a language really specifically for checking types, for inferring, checking, and proving that certain type relationships hold. As a language, it's also a purely functional language with no side effects, and it's also Turing complete, so you can actually compute anything that's computable purely at compile time in the type system. So a pro of that is that it really enables you to set up really, really, really specific static checks, so you can shift left in all kinds of ways. You can catch a lot of errors before you even run the program, because static checks at the end of the day are things that you can identify just from looking at source code. You don't even have to run it. A downside of type systems that are this rich is that they tend to have some pretty weird syntax that's not familiar to us. And in TypeScript case, it's really interesting because a lot of the types, they actually have the same syntax as the runtime code. It mirrors, but not perfectly. So you've really got to you've got that cognitive load of learning two sets of things. And I think for a lot of people, they don't even recognize the same control flow constructs in the type system as in the runtime system, but they're all there. I just grabbed one quick example off the TypeScript blog, and I just modified it a little bit for this talk, but this is basically off their blog, so it's not a super complicated one. But in JavaScript, you might just want to have a simple object watcher, where you could pass in an object with some properties in it, and it will return to you a version of that object that's still got the original properties, but it's got a couple of callback methods that you can attach a callback to, and they'll be called when one of those properties changes. So I've got an example there. If you gave it just an object with an X and a Y in their numbers, it would give you back an object with the X and the Y, but also it's got an X changed method and a Y changed method, and you could put your callback in there and get notified if X changed or Y changed. Super cool. And this is a dynamic language, so it would accept any object you like, and it will set up different properties depending on what those property names were. So we could express the runtime code, and that's what that make watch object does. I haven't put the runtime code there. Like, that's something that most of us could probably figure out. But the bottom part is a type. So we've basically got a type level function here, and we're mapping from the type of the source object, which TypeScript can see, because if you pass in an object there, it can see what properties it's got. And it's going it's basically a function running at the type level. It's going to actually call a few other type level functions to do a calculation of what these new property names are going to be and what their types are, and return that as the output type. So that type is actually used where it says T and, I won't go into the details of that, but it's basically a type level function. So it can do the same computation statically as the program is doing dynamically. So the way that works in practice is that you can say, hey, I want to make a watched object with first name, last name, and age. So if I now go person.on, I realise now that my previous slide had an error in it. The callback that it adds is on, but it's strongly typed for the different strings that you could pass into it. So I want to listen for changes, first name changed, and then you can supply your callback. That's fine, because that's valid. The second two, they're errors, because the first one's saying, well, you can't say first name, it has to be first name changed, and the second one's just a plain old typo. So those are things that before they would have just only been discovered at runtime, and now you can find them at compile time. And not only that, it's not rigid. You don't have to set up separate types for every possible different object. It's like whatever the shape of the object is, it will do a type level function and work out what the shape of this watched object that corresponds to will be. And this kind of thing, this is a simple example, but with TypeScript, you can go way beyond that. I would love to do a talk on cover more things, like web servers, for example. Finally, has everyone got their popcorn ready? OO versus FP. So if this was a conference, this would be such an interesting and controversial topic. I think that language paradigms, which we haven't really touched on yet, that would be covered here. Language paradigms is the closest thing our industry has to religions. It's very dangerous to, you got to watch what you say. Fortunately for me, I realized in running through this talk a few times that I wouldn't have time to really do it justice. So, sorry guys, put the popcorn away. I did try, but I really found that in a little 5-minute window, you really couldn't do justice to the debate. So that one, if that's something that you guys are interested in, maybe I'll pitch it for DDD next year. I thought, though, I should at least try and find some good trolling quotes about the two paradigms. The funny thing was, it was super easy to find them for object-oriented, but it was very, very hard. I could basically only find this one sort of meme quote for functional languages. Okay, end note. In a nutshell, the things we're interested in programming language design in ways that it can actually make our lives better and easier and safer is convenience. We want less of these rabbit holes where you get lost trying to find a good solution. We want convenience, that we can express things at a high level in a reasonable amount of time. And the way we do that is by leveling up human capabilities by taking into account human weaknesses. Correctness, we just want to squeeze bugs out of the system by design, make them less possible to even express by shifting left. and in particular with expressive type systems. And I think when I pitched that we'd look at things that will emerge in the future. This is a big area where I think there's a lot of work going on in programming language design. And finally, we need to embrace trade-offs. So different languages express some things better than others, and I think it's going to always remain the case that we should choose the best programming language for the job. And that's it. Thank you very much.
Thank you very much, Troy. What an engaging, thought-provoking talk. I think one of the most gripping of today. So thank you. Now we're going to open up the floor for questions. Do we have any questions for Troy? This one over here.
What do you think drives people to be so, some people to be so emotional? Oh, sorry. What do you...
Maybe it's turned off.
No, it's not on. Can I just yell?
Yep. Try it again.
I can hear you, Nick, so I can repeat your question if you...
Hello? Okay, that's better. What do you think drives some people to be so emotionally attached to a certain paradigm or a certain language, if you've seen it happen?
Well, I think it's like a bit of a minefield even discussing it, because I made an analogy to religion, and there's probably there's a deep analogy there. So I would say sometimes it's you've grown up knowing one thing all your life, and it's very difficult to hear things that say you're wrong. Or even if you came to a certain way of, say, developing software in a certain paradigm yourself, you may have invested a lot in doing it that way, and maybe people with really different views from you just, it's risky to embrace new ideas sometimes because you've invested a lot in what you already know. And typically no idea is perfect, so you can always point flaws in the other people's way of looking at the world.
So a little bit of resistance to change and fear of the unknown.
I think so, yeah.
Thanks. Any other question?
That's great. Thank you, everyone. Lunch is served out in the foyer. And a big round of applause to Troy.
Your love carries me through all the valleys and the darkest places. Your love carries me through all the valleys and the darkest places. Your love carries, your love carries.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking
God,
at
this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
Hey, bigger customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking
God,
at
this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never, ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Pink Beret. As you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the pink, no matter the client, no matter where I was working, it always was a pink background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so pink beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Yeah, whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Tell me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. But I really needed to wind down before bed, so I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. And we're looking at
God, this is like my dream come true. I've always wanted to join Scott Henselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can't we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking
God,
at
this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never, ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Pink beret. As you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the pink, no matter the client, no matter where I was working, it always was a pink background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so pink beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Yeah, whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Tell me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. But I really needed to wind down before bed, so I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. is nerds nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Henselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the Ultimate Keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our offices. We're looking
God,
at
this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never, ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Being beret, as you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the pink, no matter the client, no matter where I was working, it always was a pink background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so pink beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Tell me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. But I really needed to wind down before bed, so I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Okay.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. is nerds nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Henselman's troop.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Huh. Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never, ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Being beret, as you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the ping, no matter the client, no matter where I was working, it always was a pink background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so pink beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.
Be better, build better. Personally, I always try to be better than yesterday. That's always been me, so I'm better than yesterday and I'll be better tomorrow.
I also got a lot of training opportunities on Planet because there's a vast library of training courses available that I can just access anytime. Before I joined Planet, like when you want to learn something, Google first, right? And then when you Google something, you always have to pay for something, and that's not what I want to do. So it's really good that Planet offers these free courses for me, and I don't have to feel pressured about buying something just so I can improve my skills and use them for work. Planet always encourages learning, and learning is a good way to just accelerate your career growth.
Top Gun of testing is it's awesome. It's really cool to be around people who are so passionate, so driven to do what they do, and who always want to learn and get better. I think that's really important, and I think it's going to be a driving factor going forward in the IT industry in general.
Top Gun is the best of the best, and for me, it's if you want to grow up in your career, you are at the right place because we have got all the training materials, right people, and right opportunities. Whatever you need to progress in your career, you have got everything in here to boost your experience and boost your personality. Everything in a compact pack. That's what Planet is for me.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Okay.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Tell me the best thing that's happened while I was gone.
I made sure Dad ate healthy like you said. He even tried the broccoli. Eat it. Then I helped him make his work much better. And we found the perfect outfit to wear to my party. But I really needed to wind down before bed, so I turned my hand into a starfish.
My best thing is you being back.
By applying market-leading technology solutions through our lifecycle services, we help clients realize business outcomes through our advice, integration, and operational services. MOQ Digital helps clients to fully understand their IT needs, adopt the right solution, and provide ongoing support to maximize their investment.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah.
Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Henselman's group.
What do you want?
Go.
We got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0, it's an identity platform. Fast, easy logins, just what the boss wants.
Can we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay, you can see me.
Yeah, we can see you.
Tasty to eat for lunch. Now, our next speaker is Trent Jones. His talk is going to be about architecture for all. Trent from AI Media has been designing, building, and testing software for over 10 years across a wide variety of industries. He has a passion for DevOps and inclusive software, along with a lifelong love of sharing and learning. Over to Trent.
Thank you everyone for joining me today. So this is a little talk I've been developing across a number of different engagements. In my previous life I was a consultant, so I did a lot of architecture diagramming and the various likes. So thank you for joining me. First off, thank you to all the sponsors. Today wouldn't be possible without them all, so it's really appreciated. I know they rock up year after year, so yeah, really appreciate them. So I thought I'd start off with a quote. Architecture represents the significant design decisions that shape a system where significant is measured by the cost of change. And the really important part here for me is that last part of the sentence. Significant is measured by the cost of change. These decisions in your architecture diagrams, in your architecture, they have a cost associated with them. Changing them is not as simple as just swapping a component out. Generally speaking, maybe you've got microservices and it is easy, but generally speaking, they're quite complex tasks. So I really like that quote. It's a great setting. Onto diagrams. Who's audience participation? Who's done a diagram before? Who's done an architecture one? Nice. How many of you have done it on a whiteboard? Mostly on a whiteboard? Yeah. How many have done like more professional, used a bit of software and had to store it in the system where everyone references? Cool. So we're all pretty familiar with architecture diagrams then. So some examples. This one, lots of boxes, barely any labels. There's a bunch of arrows in the middle there that are so close together you can't even see where they're going. I'm probably guilty of doing this at some point in time. There's been some complex systems in the past. But overall, you don't get a great picture of what's going on here. There's lots of pretty colours and a few arrows, but not much else to really tell you what this system does or how it behaves. What about this one? Same sort of thing. It's a little bit more spread out, so it's got that going for it. Bit better use of colours, objectively, maybe, perhaps. Few more labels, again, perhaps. There's actually a label on one of the arrows there, which may or may not be useful to you. But at the end of the day, it's still kind of difficult to see what's going on with this architecture diagram. And then lastly, I have this pretty whiteboard drawing. This is probably, honestly, the best out of all of them. It's even got some users in there down the bottom in green. Lots of the arrows and the data flow is actually labelled. But yeah, they're all, at the end of the day, they're all just boxes. That's boring. What the hell are these, what are these actual components? Is it like an EC2 box running Java Spring Boot, or is it a Lambda microservice? Like, what's actually going on in this architecture? Who knows? So stop it. Don't do it anymore. Don't like it. This is a slide that I didn't delete when I was meant to, so let's skip that one. My purging last night clearly missed a slide. So I wanted to talk through a scenario because I thought that was the best way to kind of illustrate how we might go about designing better architecture diagrams. So I came up with a cannery. Don't ask me why, my brain works in weird ways. So products are randomly sampled as they go along the conveyor belt. They're tested for anomalies, and we take some action. Right, so there's something that does that random sampling. There's something that detects that random sample event and actually makes a change in the system. We have to do something to take that sample from the product. And then we get results back. We get a pass or fail from that sample. And again, we have to take action if it fails. If it's good, then we continue doing whatever it is a cannery does and we profit, hopefully. So This is a plausible architecture, right? It's not a good one, I'll give you that, but it's a plausible architecture. We have a sensor, it's sending some sort of data to a sampling engine. There we have a pretty box. The box I said don't do, because boxes are not good. If the sample fails, it goes around to a staff member. Don't know what sort of staff member. Is it the cleaner, or is it the manager? Like, who are we actually sending that to? Is it the CEO that gets the message? And then the staff member sends something back to the sensor. What are they sending back to the sensor? There's not a lot of information going on here, but I can almost guarantee that there's architecture diagrams like this out in the wild. So all we can really tell from this with any great certainty is that when we get sample results back, we do something with those sample results, right? We could see those data flow labels, the sample passed and sample failed. That's the only real certainty we can get out of this architecture diagram. So let's iterate. So now we have a production line. We can see what's actually happening here. From the production line, there's two-way data flow between the random sample sensor, which has a better name now, by the way. It's not just a sensor, it's a random sample sensor. We've got really descriptive labels associated with these things. The random sample sensor, we still don't know what it's doing. It's just passing something into a black box sampling engine. We still don't know what that sampling engine does. We can see when it passes, we actually go and restart or continue the production line. That label might need some work. And we can see the manager at some point presses the start button, but we don't really know when that is. So, arguably better, maybe worse. Hopefully it illustrates a point though. So now we can see that we've got something generating a sample event. We know a bit more about what's happening in this system from this. There's probably a few other bullet points we could include there. We know that it's running against a production line. We know that it's a manager that takes action on this system. Overall, we're starting to get a better picture of what this whole system does. But we can do better. So let's try. So now we have a lot more going on here. I'll try to run through it really quickly for you. Of key note is we no longer have that black box sampling engine, right? We have individual components. We have an SQS queue. We have a Lambda that takes the sample and does something with it. We have we can see that the sample goes through some sort of analyzing system. Don't know what, I'm not a cannery manager, so don't ask me. And then it gets processed by another Lambda. So we know, instead of that single black box that we thought we had, we actually have 3, arguably 4 different components there, which is massive amounts more information that we can convey to our users, our stakeholders, anyone who's interested in this system. Brand new devs that join the team. You can go, oh yeah, cool, we work with 2 Lambdas and an SQS queue instead of just, there's this black box and you'll eventually figure out what it does. There's tons more information here. We can see when it fails, we actually send a notification to the manager. It doesn't just nebulously somehow get to the manager, who then analyzes the results. And there's some subjectivity here, clearly, because otherwise we wouldn't need to analyze the results. The manager probably wouldn't even need to be involved. And then you can see that based on analysing the results, they'll restart the production line. Perhaps there's other steps they have to take before they can do that. I would assume they have to remove the crappy product before they restart it. Again, I don't actually know how canneries work. But that's the basic premise, right? We want to convey exactly what's happening in this system. Clear labels for everything. Your components, it's not just a Lambda, it's a Lambda that takes a sample, it's a Lambda that processes sample results. It's very clear what those individual components are doing. And that then helps you to convey meaning to the rest of the people involved in the project. So this is a real world example. This is something that I used at a client. This is actually part of a smaller part of a larger architecture. So this is one component out of 4, 6. There was multiple VPCs, peering going on, and it was all illustrated in the diagram where I used a little pipe symbol to indicate that there was peering between the various VPCs. You know, use your imagination here. Use something descriptive that's not just a box and an arrow to get your point across. In this particular case, we're talking about a step function. You can see we're using the diamonds to indicate decision points in the process. The grey box, I'm hoping it's grey on my screen, the bit in the middle there, with the map states is actually a parallel state where it takes multiple results and spins up multiple lambdas concurrently. Not sure that's the best representation, but at least it gets the point across that something different is happening at that particular part of the process, which is the goal here, is we want to communicate exactly what's happening. And you can start a discussion around that point. You can go, hey, product owner, we're actually spinning up 20 lambdas here, right? This is very different to just spinning up one lambda. They're all processing things concurrently, and we have to take certain actions as a result. Down the bottom, you've got external integrations with MuleSoft. That's as far as I went with this particular diagram. You could go further. The MuleSoft actually pointed at SAP. Whether that adds value or not is up to you. The one thing this doesn't include is people. That said, this system doesn't actually really have people in the process. It's a fully automated system. So perhaps not the best example, but I thought it would be interesting to include a more beefier example of what I'm trying to get across here. Cool. I'm going really quick, of course. So, look, you see, really quick. That's basically the end of my talk. So, the key takeaways here are build architecture, design architecture that includes everyone. Don't build these little black boxes that only the technical experts understand. You lose so much value. Your POs, they don't know what's going on with these little black boxes. You tell them there's a lambda that's doing something, instantly they go, oh, cool, I actually understand what that is. You might have to explain to them how a lambda works, but they're going to feel more connected to the project. They're going to be more interested in what's happening. I've seen it time and time again. The good POs, even the mediocre POs, they are way more involved in the process if you encourage them and include them in the whole thing. They want to be involved in this. At the end of the day, that's their product, right? They want to know what's happening with their product. They are the owners. So really encourage them to get involved in this process and build a process, build a diagram that does encourage them to do so. Things that will help you do this, single responsibility principle, right? That single black box was split into 2 lambdas and a queue, and they all did one thing. There was a lambda that took a sample. I don't know how that works on a cannery factory. Maybe they activate a different conveyor belt. Who knows? But that's all it does. It just takes a sample when it responds to that random sampling event. And then the other lambda that processes the results and says it's a pass or a fail, right? That's all it does. It figures out whether the results are a pass or a fail. It is very simple architecture. It's easy to understand, and everybody can understand it, which is the whole point. We want people to understand. We want people to go, oh, can I add this particular component? What's the impact of this particular feature or change to the system? And if they understand the whole system, they're going to be able to have more of a meaningful discussion with you about that. Readability and discoverability. I mentioned earlier in the talk, new devs are going to understand this a lot quicker than if I just did that black box outside, or maybe the event bridge and the step function, right? Having all the individual components is going to be way easier to understand and get them up to speed. And that's what we want, right? We don't want to have to spend a month teaching the new dev all the different parts of the system. We're going to go, hey, we need to make this change to lambda XYZ. Go make that change, and they can go do it without any other involvement. So it's a really great way of onboarding people quick and everyone getting up to speed and everyone understanding the system. And the last thing I've kind of already touched on this, opportunities to enhance your workflow, right? You're not always going to see everything. Just because you're the architect doesn't mean you always know best. Just because you're the senior dev or the tech lead, just because you're the PO doesn't mean you know the best workflow here. By having an architecture that everybody understands, you can all work together and spot opportunities to improve the workflow, to enhance the workflow, to add new business cases and value to that workflow. And that's it, that's me. So thank you very much for coming to my talk, and question time. Sorry.
Thank you very much, Trent. So it's not only about making inclusive software for your customers, it's about making inclusive systems so that you can basically communicate better with the team of people that you're working with, all the way through from exec to your junior developer.
Absolutely.
Very good, thank you. Now we're going to open the floor up for some Q&As. Has anyone got a question? Just up the front.
Possibly a loaded question. Have you have you heard of the C4 model of architecture diagrams?
Recently, yes.
Okay,
yeah, very similar. I considered adding that to this talk, and you could, if we look at, say, this particular model, you could probably apply that here and say the two big black boxes are one level of the C4, and then you drill down another level and you get a view of the event bridge and the step function and the database, and then another level and you get the internals of the step function, and that would apply there. But yeah, organically came to the same conclusions apparently. I only discovered it in the last couple of months.
You've reinvented it perfectly. We discovered it ourselves about a year ago.
Oh, nice. Yeah, how's it working for you?
It's brilliant. Yeah.
Nice, excellent.
Yeah, it basically, what you showed there, it really opens up the magic black box.
Yep.
Yeah, more people can understand the system. And
Yeah, great.
Once you do that, more people can go, oh, hang on, actually, that's a bit crap.
Yeah, yeah. It leads to an improved system, though,
Yeah,
when
exactly,
they say that, right? So, yeah, it's good. Cool.
Thank you.
Any more questions?
Any more questions?
Another one at the front there.
Have you got any advice for people who are reviewing someone else's architecture diagram? Any sort of red flags to look out for and that sort of thing?
Oh, yeah, that's a good one. No boxes. Yeah, look, I can't think of anything off the top. I've not done a lot of reviews, right? I tend to either pick something up and try and figure out what's going on, or I'll be building the diagram myself. I guess the only thing I would perhaps consider when doing a review is maybe build it yourself, do the diagram yourself and see what the differences are, and make sure that you have actually captured all the aspects of the system. Might be a good way of doing it. But yeah, I've never done reviews before, so that's purely guesswork, unfortunately.
Any more questions?
Are there any particular tools that you found sort of helpful or useful in terms of your architecture diagrams?
Yeah, look, I mean, there's definitely tools out there that will generate a lot of this stuff for you. There was, I can't remember the name of it, there was a recent one that works really well with ARM templates and the Azure system. I'm not sure if there's equivalent for AWS. These particular the big real world diagram, I did that in, sorry, I just realised I'm not on the screen, it's there. The big real world diagram, I did that in Visio. It has all the nice icons and everything else to work with whatever platform you're using. But Draw.io as well, free, open source, has same set of pictures and diagrams and everything else. And you can sync it to Dropbox and OneDrive and all the rest, and they're really useful tools. I haven't used Lucid, but I do know of Lucid. Yeah. Yeah, they're the most tools I know about.
Any more questions? No. Okay. Well, thank you very
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey friends, I'm Scott Hanselman, and I was told to give you a tour of my office. This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I always wanted to join Scott Hanselman's group.
What do you want?
Go.
we got a little problem. As you know, our motto is, you need a professional bodyguard delivered to your door in less than half an hour, you got it, buddy. But without an app, ain't no bodyguard getting delivered nowhere. So, where are we with that?
The app is almost ready. We just need 3 more days?
We need it ASAP.
Okay, team, what's the status on the app?
We're good to go, except our login experience is a disaster.
We need something to keep our users' data private.
And to keep the hackers out.
And it needs to work flawlessly because...
Because I don't want to lose one single customer.
I hear you, so let's use Auth0.
Auth what now?
Auth0. It's an identity platform. Fast, easy logins, just what the boss wants.
Can't we make our own authentication service?
Come on, the ultimate keymaster, you know we don't have that kind of time.
We need to confirm identities with passwords, fingerprint scans, whatever the users like to use.
Auth0 can do that.
Yeah, but it needs to be secure. We can't have our app compromised by breaches.
Not a problem.
And it needs to scale if we get hit with a ton of traffic. And if it stalls or freezes up, I will get fired.
We can do this.
Could you guys stop? That's really distracting. We did it.
It's done.
Already?
Yep.
I think our customers are gonna love it.
I got a real app now, folks.
You know what? I want a bodyguard.
Hey, we got a customer.
Huh. Cool app. My name's Steven.
What's up, Steven?
We can do this.
Mark, where are you, Mark? Turn your camera on.
Okay. You can see me?
Yeah. Yeah, we can see you.
Hey,
friends. I'm Scott Hanselman, and I was told to give you a tour of my office.
This is Nerds Nerding. What we're doing is we're talking to people all over the world because we're stuck in our houses. We're looking at
God, this is like my dream come true. I've always wanted to join Scott Hanselman's group.
What do you want?
Ambition is a fearless hunger for success. It drives us to challenge the way things are, to pursue what seems insurmountable, to keep going when others would stop. Ambition is how a global manufacturer is using AI to empower employees with disabilities. Ambition is how a company managed an overnight transition to remote work for 100,000 teammates. Ambition is how a children's hospital built an app to reduce stress for families. Ambition is how a law firm rallied against a malware attack to reclaim control and prevent a devastating breach of client confidence. At Insight, we know the power of ambition. We've grown from a small technology provider founded by two young brothers to a Fortune 500 company offering IT services and solutions for all. For more than 30 years, people have trusted us to turn ambitious projects into meaningful outcomes. What will your ambitious story be? Now is the time to do big things together. Now is the time to be ambitious.
My name is Carol. I'm a test engineer. My call sign is Special K. You might be familiar with it. You see it in cereal boxes. It's my call sign because I like eating. I eat a lot. When people see me, they always see me eating, and they always ask me, Carol, why are you eating? And I think that just when they see the cereal box, they say, okay, that's Carol.
Hi, I'm Joshni. I'm a test engineer. They call me Jester because I always have a smile on my face, whatever situation I'm in.
My name is Jaden. I'm an automation engineer here at Planet. My call sign is Digit because I'm a huge maths nerd. It is my primary major, but I often get called out on how I never, ever stop talking about maths. I just love maths.
I am Cassandra. I am a test automation specialist. Being Beret, as you can tell by the accent, I am French. Very prominent accent. So the beret completely makes sense. As for the ping, no matter the client, no matter where I was working, it always was a ping background with Hello Kitty riding a unicorn. It does not reflect who I am outside, clearly, but I think it brings a little bit of sparks and joy, and so yeah, so ping beret it is.
My name is Kong. I'm a consultant here at Planet. When people ask me how to pronounce my name, I always say, I'm not the king, but the Kong. But after joining Planet, I am the king and I'm the Kong.
Work to inspire is very something that we live by, I believe. We definitely see how much passion we have for quality and how much we want to convey this as a client. We don't just go for target, we always try to go a little bit further, and we try to inspire each other by learning new skills, having new challenges and taking them, and I think it's very inspiring.